everyone, today we are diving into something that's all around us. It's data. Every time we use an app, shop online or watch a video, data is being created. But what do we do with it? That's where data analytics comes in. Let's break it down together. Let's start with basics. Data analysis is a process of looking at data to find useful information. Think of it like being a detective, but instead solving crimes, you're solving business problems, finding trends, and figuring out what people like to do. It's all about making sense of numbers and patterns so we can make smarter choices. So what exactly is data analytics? It's a bit more than just looking at numbers. Data analysis is the science of collecting, cleaning, and examining data to discover insight and make decisions. Imagine you own a coffee shop. Data analytics can help you know what drinks are selling best, what time of the day is busiest, or even why customers don't come back. It's like turning new numbers into stories we can understand and act on. Now, who does all this work? That's the job of a data analyst. They are like translators. They take complex data and turn it into plain English so business can make better decisions. A data analyst uses tools like Excel, Python, or dashboards to dig into numbers and explain what they mean. They're not just number crunchers, they are problem solvers. When we talk about data analytics, we are really talking about asking the right question and using the data to answer them. There are four main types of data analytics, and each one helps answer a different kind of question. First up, we have descriptive analytics. This is all about answering the question, what happened? For example, how many people visited our website last month? It's about looking back and summarizing the facts. What occurred, when, and how much. Next is diagnostic analytics. This goes one step further and asks, why did it happen? Say our sales suddenly dropped last week. With diagnostic analysis, we dig into the data to find out why. Was it bad weather, a holiday, or something entirely different? This is where data detectives get into work. Now let's look at the future with the predictive analysis. Here we ask what might happen next. By spotting trends in past data, we can make more smart guesses. Like, will we sell more ice cream next month if the temperature goes up? It's not a crystal ball, but it's the closest thing we have got in the world of data. And finally, there is predictive analysis. This type of analysis helps us decide what should we do about it. For example, should we run a discount next month or launch a new product to boost the sales? It often combines predictive suggestions and sometimes even automated by AI systems. Before we dive into complex tools, let's start with something familiar, Microsoft Excel. It's more than just rows and columns. In this section, you will learn how Excel can help you analyze data, uncover insights, and generate clear, actionable reports. Let's turn simple spreadsheets into powerful decision-making tools. Every great analysis starts with the right data, but not all data is easy to work with. In this section, we will explore how to collect the data from different sources, whether it's structured, semi-structured, or unstructured, and how to handle it very smartly. Let's get hands-on with real-world data.
Now that we have looked into some operations which we can perform in Excel using filter or sorting the data, creating your tables, let's also quickly look at functions and formulas which can be used for doing some easy calculations or computations. Now, Excel can be used in different kind of data analysis. So for example, you have different inbuilt functions which can be used, and we can always check for a particular function. So for example, if I wanted to look at a particular function, I could just type in here something, for example is, and then it shows me all the possible functions, and you can always have a look at the detail of the function. For example, you have is even, which will return true if the number is even. If we would say is logical, so I could search for is logical, and that tells me whether a value is logical value, true or false, and returns your value true and false. Now we can obviously say subtotal. So you can search for any of these useful functions, and that tells me what this function can be used for. So returns a subtotal in a list or a database. You have many other such functions such as integer, sum, average. You may be interested in working on truncating some data, getting the absolute value, getting the square root, basically getting a count or getting a max value. You can look for any particular functions within your Excel sheet. Now you also have other functions such as now or time. For example, let's look at now function. So I can search for now, and here it is. So this is returns the current date and time formatted as a date and time. So this is the function which we would want to use, and if I just give the function, it tells me what is the current time. Let's first look at the description of time here. So say for example I would want time. It says converts hours, minutes and seconds given as numbers to an Excel serial number formatted with a time format. So for example, if I would say 2 hours and then 30 minutes and 30 seconds, and if I do this, it has basically converted this into your time format. So you can always use different inbuilt functions for your work. Now we will also look at some advanced functions like SUMIF or SUMIFs. You have COUNTIF and COUNTIFs, and you can be working on various functionalities of Excel to easily help you in doing some calculations, computations, working with your data, working with your different cell values. So let's look at some example of using functions like sum or SUMIF. So for that, let's go to this sheet, and here we have some data. Now I have already applied a filter which can allow me to filter out the data. So it says find the total units that were sold in the East region. Now we know that in region we have East, and I have multiple regions. I could basically be saying unselect all and select only East and say OK, and that basically gives me the units which were sold. And if I place my cursor here and then if I did a auto sum, so it would basically give me the function which is being used, so something like subtotal, and it is basically working on your rows which is E2 to E44. And here we can just do this, so that gives me the total. But this is fine, you could do that, but it would be good if we know how do we use a function like SUMIF to do that. So here I'm seeing this is the subtotal where I'm looking at the values, and basically what I have done is I have filtered out the region, and then basically I'm getting a count. But this does not give me clearly how a sum was calculated from all the values which were listed. What we can also do is let's do a Control Z and let's get it back. So now we have our data, and we would want to get the total units that were sold in the East region. So what I can do is I can start typing in my formula, and for that I'll use an inbuilt function. So for example, I would be interested in going for SUMIF. Now it says SUMIF adds the cells specified by a given condition or criteria. When you talk about SUMIFs, this is when you could give set of conditions or multiple criteria. So let's look at SUMIF. Let's do this. Now obviously this gives me an error because the formula is not right. So we have to basically come in here and let's start with SUMIF. Now when I say SUMIF, it shows me there is a function with SUMIF which we would want to use. And here, once I open up the bracket, it tells me, okay, what is the range of data which you are interested in. So I'm interested in all the units that were sold in the East region. So we are interested in the region which is here. So I can basically be selecting this, and this tells me you are interested in the data here. So let's not take the header value. So let's say B2, and then we can go all the way to the end. So we can basically select this way. That's the data we have. Select this and hit enter. So now here it has selected B2 to B4, but we need to basically now give the criteria. So the criteria is either a value, or you can point it to a cell which has that particular value. So as per our problem statement, we are looking for the units which are sold in East region. So I can select the value East here, and then my SUMIF needs the range on which you want to calculate a sum. So let's select this, and now we are interested in finding out the sum of units. So that's basically this column, E column. So I can basically type in instead of selecting. So I can say E, and I'm interested in E2 to E44. So that basically selects the area or all the values. And now let's do this. So that basically gives me the sum is 691. Right now, this is the criteria where I have pointed it to a cell, and whatever value that cell has, well, I could have done something like this. So I could have selected East, giving the value, and then doing it. It still does the same thing, and in this way you have more clarity that you are using SUMIF. You are filtering the data, so you have given the rows, you are given the criteria, and then you have given the range on which you would want to sum up the values. Now similarly, if the question was what was the total revenue generated from binder, now we would want to find out what is the total revenue generated from binders. That means my filtering criteria will be binder, and then I want to find out the total revenue generated. So we have the revenue generated field also here, and we don't have any region to be filtered. We are just looking for binder. So let's again start doing the same thing. So we can go for some if, we can open the bracket. Now it needs the range, so we are interested in revenue generated. Now that's the summation we want, and we would want to get the range of data. So here we can basically select D2 to D44. So that's the data selected. Now I would want filtering criteria. So let's say binder, and then we need to give the range on which the sum needs to be calculated. So that's my revenue column. So that's G. So I can say G2 to G44, and that basically selects the column, and then you get your sum. So it tells me what is the total revenue generated from binder. Now I could be doing this for other things also. So say for example, if you would want to filter out something else, you could basically just drag and drop here, and then I could come here and change this to, say, instead of binder, I would be interested in, say, pencil, if that's the criteria you are interested in. Remember to change this so that you take all the values, and here we will change it to select the relevant rows, and then this is the data I'm getting. So I know that this is the revenue generated from pencil. This is the revenue generated from binder. Now this is a simple use case where we are using some if. What if we would want to use some ifs? So some ifs, let's have a look at how we get to some ifs. So some ifs is where you would want to work on doing some calculation, but then you would want multiple criterias to be met. So let's see how we get this. So here what I can do is, let's work on this problem statement which says what is the total revenue generated from central region where the item is a pencil. So that's something which I would want to check. Now, when we are answering this question, we can also look at the order in which things have been asked in the question. So it says, what is the total revenue generated from central region? So we need the total revenue generated. We know there is a revenue column. We are interested in getting the total revenue generated. We are saying the filtering criteria is central region, and we say in that we would be interested only in the item if it is pencil. How do I do it? So I can use some ifs where you can pass in multiple criteria. So let's start with some ifs. And when I start with some ifs, let's open up the bracket. So it says sum range, it says criteria range, then it gives one criteria, and you can give in any number of criterias. So for example, we are interested in total revenue generated. Now that's my G column. So let's follow in the same order. So let's say G2. So that's my first value. And then I know there are 44 rows here. So I can say G44. And you can obviously check if that has selected all the rows. Now that's my total revenue generated. So I would want the total revenue generated. So I'm saying setting this sum range. Then I need to give the criteria range. So it says from central region. So central region comes into column 2, that's B. So let's say B2 to B44. So that's my criteria range. Then you have to give your criteria, but we need to filter out the region being central. So let's select this. Now either I could point to a value in the cell, or I can just give the exact value here. We can also give a wildcard or matching pattern, so that also works. Now this one is fine. We are now also interested in finding the total revenue generated when the region is central and the item is pencil. How do we do that? So for item, we know the column is D2. So let's select D2 to D44. So that basically selects all the rows in the D column, and we need to give the filtering criteria. So let's do a comma and then just give in our value. So let's say pencil, and then let's close your bracket, and that basically gives you the result. So we need to just follow the order of our question, which says what is the total revenue generated. So we are looking at the revenue column, we are selecting all the rows. Then it says from the central region. So we need to select the region column and give the filtering criteria as central, or point to a cell which contains that value. And then it says we would be interested only in item being pencil. So then you select the column which has all the items and provide your filtering criteria, that is pencil. So that's your easy calculation of using sum if, which we compare with sum if here. So sum if here was just having your criteria. So basically you are selecting your rows, giving your filtering criteria, and then your sum range. In sum ifs, we are giving multiple condition. Now same thing can be done here. It says how many units were sold by sales representative Jones, where the cost of each item was greater than 4. So how many units were sold by sales representative? So when we talk about how many units, that's your E column. So let's start with that. So let's say sum ifs, I would be interested in E column. Then let's give the range. So it says sum range. So those are the number of units on which we would want to find the sum. Then it says you need to give the criteria range. So we say sales representative, where the name is Jones. So sales representative is in sales rep column C. So let's say C2 to C44. Now then we need to give our filtering criteria. So let's say Jones is the sales representative where we are interested, about whom we are interested in. And then the question says where the cost of each item. So cost of each item is what we are interested in. You have unit cost. So that's what we are interested in. So that would be F, and then say F2 to F44. And then you need to give your cost. So it says where each item is greater than 4. So let's select this and let's do this. So this tells me 301. Now, similarly, let's answer our third question, which says how many units did Jones sell excluding pencil item? So we would want to find out what was the total number of units that were sold, and that units or that should not include the pencil item. How do we start doing this? So let's start with some ifs. Now we know that you start with some ifs, you need to give the sum range. So we are interested in the number of units. So let's basically go in and select our number of units which were sold. So that's your column E. So I can say E2 to E44. That's where I would want to perform the sum. Now I'm saying how many units that were sold, where we are talking about sales rep being Jones. So let's select the columns C and then give the range. After that, we need to give our filtering criteria, which is Jones, and then we are interested in the items, but excluding pencil. So items is in column D. So let's say D to D44, and then we have to give our criteria. So we can say, well, that should exclude pencil. So I can basically say pencil, and let's close this and let's check. So that's my formula, which says that these are the number of units which the sales representative, whose name is Jones, had sold, and that does not include pencil as an item. Let's also look at an example of using COUNTIF or COUNTIFs. Now, both of these can be very useful when you would want to calculate certain values. So for example, if I would want to work on COUNTIF, let's try solving this problem. Now, remember, you can answer these questions using filters, and that can be an easier way. But then sometimes you may want to get the formulas so that you can make your spreadsheet and your calculation more dynamic in nature, and that will basically depend on the values in the columns or rows. So for example, if I have find the total number of times Gil has made a sale. Now if I look at my data here, it tells me that for every sales representative there is some value in the sale, and it says sales has greater than 3. So for example, Jones, you have sales greater than 3, or you have Jardine, which is sales greater than 3, and so on. So what we are interested in is doing a quick count and finding out the total number of times Gil has made a sale. How do we do that? So we can use this COUNTIF function, and if I go into COUNTIF, it says counts the number of cells within a range that meet the given condition. Now what's our condition? Our condition is Gil, and we would want to find out how many times the name, say, Gil appears or Gil has made a sale. Now I could just say COUNTIF and then open up a bracket. I need to give a range. So let's say we are interested in looking at the range. So let's say we will choose sales rep, so I can say C, and then I can say C2 to C44. Now that's my range. Let's not give that in quotes. So you have to give a range. So let's do a count if that selects the data, and then we need to give the condition. So for example, let's here give the name, which is Gil, and then close this. So that basically tells me it is 5 times Gil appears here. We can check this. So I can go in here, I can add a filter, and then might be I would be interested in looking at only Gil, and that basically gives me 5, right? So we can always do that, and we can be using formulas like this. Now what about this question, so which basically says which sales representative made a sale more than 3 times. Now it might be looking little confusing when I say, for example, let me clear out this filter. Now we have sales greater than 3, and we would want to find out which sales representative made a sale more than 3 times. Now I could basically check for every sales representative here if they have made a sale more than 3 times, and what I can do is I can just say equals, I can start with count if, then I need my filtering criteria. So that's your range. So first thing is we will choose, for example, let's choose C2 to C44, and then we need to give an criteria. What is the criteria? We need basically a sales representative. So I can choose the value here in C2, and then I can close this, and then I can say the sale has to be greater than 3, and let's check. So it tells me the Boolean value that yes, this guy has made sales more than 3 times. And what we can do is we can just drag and drop, which basically gives me the value for other sales rep. You can always check the value is automatically changing to this value in cell. And for example, let's go in here. So this is obviously 2, so it says me false, right? And you can basically get the values for all your values. So that basically tells me which sales representative has made a sale more than 3 times. Now, like some ifs, we also have count ifs where you can give multiple criterias. So for example, the question is how many orders were placed from the East region after this particular date. So we have a date criteria, we also have the region criteria, and we need to basically get the count of number of orders which were placed. Now I can in this case use count ifs, and this basically says that you can start with a criteria. So it says how many orders were placed from East region after particular date. So date is in my first column. So for example, I could say A, start with 2, and say for example, let's go A44. That should have selected all the rows, and then I need to, once I've given the criteria range, I need to give the criteria. So we are saying the date has to be greater than 10th Feb. So let's give it 2/10/2019, and then you need to say how many orders were placed. So you need to give the criteria, second criteria range. So we are looking at the number of orders which were placed from the East region. So when I would want to look at the region, that's your column B. So I can basically say B2 to B44, and here I would basically give my criteria. So the criteria is East. Let's give that. And once you have done this, you would want to find out the total number of orders. So let's select this, and if I do this, it tells me 13. Now, is that right? So we are looking for your date, your region being east, and then getting the total number of orders. So here I can just do a count if I'm saying A2 to A44, wherein I have given the date criteria that it should be greater than 10th Feb, because I do not want to count 10th Feb. It says after 10th February. And then you are saying the region has to be east. So we would want to find out the total number of orders. So my region is east, and that gives me the result. Now, similarly, you can also find out how many times Gil sold pencils. So here we will have to give the range. So let's start with count ifs. Now here I would want that item is pencils, so we can as well select column D to D44. Then you have to give your criteria, so that's your pencil, and then we are looking for sales rep, which is Gil, so that is my column C. So let's say C2 to C44, and the value should be just Gil. So it tells me it's twice where Gil has sold pencils. So we can obviously check this by going in here, choosing my filter, and then let's search for rep being just Gil. Okay, and now we are interested only in the item being pencil. So I can say, well, let's get to pencil only, and that tells me twice. So you can obviously re-verify using filters, but using functions or using formulas, it is always good to calculate, and that can be making your computation and calculation more dynamic.
Now it's time to level up. Python is one of the most powerful tools for modern data analysis. In this section, you will see how Python helps read, clean, and prepare the data faster and more efficiently than traditional tools. If Excel is your bike, Python is your supercar. Alright, let's start with foundation, data collection, and mastering data handling. This is really about two key things. First, it's about gathering information from data from various places like different documents or sources. But just having the data isn't enough. The second and equally important part is mastering how we handle the data. This includes organizing it, cleaning it up, analyzing it to find patterns, and ultimately using those insights to make better decisions or understanding things more clearly. Think of it as not just collecting puzzle pieces but also knowing how to put them together to see the bigger picture. Without both of these aspects, our ability to derive meaningful value from the data is significantly limited. Next, we'll speak about structured data. One of the most important source of structured data and prime example of that is database. Think of a database like a very well organized digital filing cabinet. Everyone inside it is arranged in a specific way. This predefined structures make it really efficient to find and analyze specific information. Popular examples of these include MySQL and PostgreSQL. The big advantage here is that because everything is so organized, we can quickly and easily query and analyze the data. This structure is key for applications that need fast and reliable access to specific piece of information. Another common type of structured data sources that you have likely encountered are CSV files and Excel spreadsheets. A CSV file is like a very simple table sorted in a plain text file where values are separated by commas. It's great for basic data sharing. Excel, on the other hand, is more powerful spreadsheet format that allows for formulas, charts, and multiple sheets. It's really useful for doing more in-depth analysis and creating reports. Both of these formats are also very accessible, meaning many different software programs can easily read and work with them. They serve as essential tools for both quick data exchange and more detailed individuals or small term analysis. Moving on, we have semi-structured data sources, and here we'll focus on APIs. Think of API as a digital messenger or a bridge that allows different software systems to talk to each other and exchange data. When you use an app on your phone or order food, for example, the app uses API to communicate with the restaurant system. This data is often exchanged in formats like JSON or XML. To get information through API, one system needs to send a specific request. The great thing about API is they often provide real-time access to data to integrate smoothly. Understanding API is increasingly important in today's interconnected digital world. We just mentioned JSON, so let's take a closer look at it. It stands for JavaScript Object Notation, and it is very popular format for semi-structured data, especially on the web. Think of it as a way to organize information using key-value pairs, kind of like a dictionary. It's designed to be relatively easy for humans to read and for computers to understand. JSON can also handle more complex data by nesting these key value pairs or using lists. Because it's so widely used in web application and for transferring data, most programming languages have built-in tools to easily work with JSON. Its flexibility and readability have made it a cornerstone of modern web development and data exchange. Now we move on to unstructured data source, and one way to get data from them is through web scraping. Imagine you want to collect information from many different websites. Web scraping is an automated process that uses computer programmers to go to these websites and extract the data you need instead of manually copying and pasting everything. It's used for things like gathering available information or doing market research. There are special tools and libraries, especially in Python, that help with this. However, it's really important to be ethical when web scraping and to be aware that websites can change, which might break your scraping program. While powerful, web scraping requires careful consideration of ethical and technical aspects. This slide will give you a broader view on how data is organized in files and where it can be stored. When we talk about file formats, we are referring to different ways data can be saved. We have text-based formats like CSV and JSON, which are human-readable, and binary formats like databases and image files, which are more computer-oriented. When choosing a file format, we need to consider things like how structured the data is, how efficiently it is stored, and whether different systems can use it. Then when it comes to data storage, we have options like storing data locally on our device or on a network shared by others or in the cloud. We also use database for storing large amounts of organized data. When choosing a storage solution, we need to think about scalability, cost, how easy is it to access, and security. The choice we make here have a significant impact on how we can work with and manage our data. Clean data is equal to smart insights. Before analysis, we need to clean the mess. Missing values, duplicates, outliers, you name it. This section shows how to tidy up your datasets using tools like Pandas in Python and dplyr in R. Because clean data means clearer decisions.
Okay, so now that you know how to install Python and if you have installed Python, let's take a look at what are the various libraries that are available. So Python is a very easy language to learn, and there are some basic stuff that you can do. For example, adding or printing a hello world statement and so on without importing any specific libraries. But if you want to perform data analysis, you need to include or import some specific libraries. So we are going to talk about those as we move forward. So Pandas, for example, is used for structured data operations. So if you, let's say, are performing something on a CSV file, you import a CSV file, create a data frame, and then you can do a lot of stuffs like data munging and data preparation before you do any other stuff like, for example, machine learning or so on. So that's Pandas. SciPy, as the name suggests, it provides more scientific capabilities. Like for example, it has linear algebra, it has Fourier transform, and so on and so forth. Then you have NumPy, which is a very powerful library for performing n-dimensional or creating n-dimensional arrays, and it also has some of the stuff that is there in SciPy, like for example linear algebra and Fourier transform and so on and so forth. Then you have Matplotlib, which is primarily for visualization purpose. It has again very powerful features for visualizing your data, for doing the initial what is known as exploratory data analysis, for doing univariate analysis, bivariate analysis. So this is extremely useful for visualizing the data. And then Scikit-learn is used for performing all the machine learning activities. If you want to do anything like linear regression, classification, or any of this stuff, then the Scikit-learn library will be extremely helpful. Let's talk in a little bit more detail about each of these libraries. So SciPy, as the name suggests, is a scientific library, and it very specifically, it has some special functions for integration and for ordinary differential equations. So as you can see, these are mathematical operations or mathematical functions. So these are readily available in this library, and it has linear algebra modules, and it is built on top of NumPy. So we will see what is there in NumPy. So this is again, as the name suggests, the num comes from numbers. So it is a mathematical library, and one of its key features is availability of an n-dimensional array object. That is a very powerful object, and we will see how to use this. And then of course you can create other, let's say, objects and so on. And it has tools for integrating with C++, and also Fortran code. And then it of course also has linear algebra and Fourier transformation and so on, all these scientific capabilities. Okay, what else? Pandas is another very powerful library, primarily for data manipulation. So if you're importing any files, you will want to create it like a table. So you will create what is known as data frames. These are very powerful data structures that are used in Python programming. So Pandas library provides this capability. And once you import the data into data frame, you can pretty much do whatever you're doing like in a regular database. So people who are coming from a database background or SQL background would really like this, because they will feel very much at home, because it feels like you're viewing a table or using a table, and you can do a lot of stuff using the Pandas library. Now, there are two important terms or components in Pandas, the series and the data frame. I was just talking about the data frame. So let's take a look at what are series and what is a data frame. So within Pandas, we have series and data frames. So series is primarily, some of you may also be knowing this as, let's say, an array. So it's a one-dimensional structure, data structure, if you will. So in some other languages, we may call it as an array, or maybe some others, probably an equivalent of a list. In R, perhaps, I'm not very sure on that aspect, but yes. So this is like a one-dimensional storage of information. So that is what is series. Whereas data frame is like a table. So you have a two-dimensional structure, you have rows and you have columns, and this is very, people, as I said, who are familiar with SQL and databases will be able to relate to this very quickly. So you have like a table, you have rows and columns, and then you can manipulate the data. So if you want to create a series, this is how you would create a code snippet. And as you can see, the programming in Python is very simple. There are no major overheads. You just need to import some libraries which are essential, and then start creating objects. So you don't have to do additional declaration of variables and things like that. So that is, I think, one key difference between Python and other programming languages. And what does this series contain? It has to contain these numbers 6, 3, 4, 6, and X is my object consisting of the series. So if you just say X, it will display the contents of X, and you will see here that it creates a default index. Then you have data frame. So if you want to create a data frame, as you can see, the series is like a one-dimensional structure. There is just like a row, one row of items, whereas a data frame looks somewhat like this. It is a two-dimensional structure. So you have columns in one dimension, and then you have rows in the other dimension. How do you create a data frame? You need to import Pandas, and then you import. In this case, we are basically creating our own data. So that's the reason we are importing NumPy, which is one of the libraries we just referred to a little bit before. So we are using one of the functionalities within NumPy to create some random numbers. Otherwise, this is not really mandatory. You probably will be importing the data from outside, maybe some CSV file, and import into the data frame. So that's what we are doing here. So in this case, we are creating our own test data. That's the reason we are importing NumPy as NP. And then I create a data frame saying pd.dataframe. So this is the keyword here. Similarly, here in this case, while creating series, we said pd.series, and then you pass the values. Similarly here, you're saying pd.dataframe. Now, in order to create the data frame, it needs the values in each of these cells. What are the values in the rows and what are the values in the columns? So that in our example, we are providing using this random number generator. So np.random is like a class or a method that is available in NumPy. And then you are saying, okay, generate some random numbers in the form of a 4x3 matrix or 4x3 data frame. The 4 here indicates the number of rows and the 3 here indicates the number of columns. So these are the columns, 0, 1, 2 are the columns, and these are the rows. Here 0, this is 1, this is 2, this is 3. Okay. And once again, it will, when you display df, it will give us a default index. There are ways to omit that, but at this point we will just keep it simple. So it will display the default index and then the actual values in each of these rows and columns. So this is the way you create a data frame. So now that we have learned some of the basics of Pandas, let's take a quick look at how we use this in real life. So let's assume we have a situation where we have some customer data and we want to kind of predict whether the customer's loan will be approved or not. So we have some historical data about the loans and about the customers, and using that we will try to come up with a way to maybe predict whether loan will be approved or not. So let's see how we can do that. So this is a part of exploratory analysis. So we will first start with exploratory analysis. We will try to see how the data is looking. So what kind of data? So we will, of course, I'll take you into the Jupyter notebook and give you a quick live demo. But before that, let's quickly walk through some of the pieces of this program in slides. And then I will take you actually into the actual code and do a demo of that. So the Python program structure looks somewhat like this. The first step is to import all the required libraries. Now, of course, it is not necessary that you have to import all your libraries right at the top of the code, but it is a good practice. So if you know you are going to need a certain set of libraries, it may be a good idea to put, from a readability perspective, it's a good practice to put all the libraries that you're importing at the beginning of your code. However, it is not mandatory. So in the middle of the code, somewhere, if you feel that you need a particular library, you can import that library and then start using it in the middle of the code. So that's also perfectly fine. It will not give any errors or anything. However, as I said, it's not such a good practice. So we will import all the required libraries. In this case, we are importing Pandas, NumPy, and Matplotlib. And in addition, if we include this piece of code, %matplotlib inline, what will happen is all the graphs that we are going to create, the visualizations that we are going to create, will be displayed within the notebook. So if you want to have that kind of a provision, you need to have this line. So it's always a good idea when you're starting off. I think it's a good idea to just include this line so that your graphs are shown in line. Okay, so these are the 4. We will start with these 4 lines of code. Then the next step is to import your data. So in our case, there is a training data for loans by the name loan p_train.csv, and we are reading this data. So in this case, you see here, unlike the previous example where we created a data frame with some data that we created ourselves, here we are actually creating a data frame using some external data, and the method is very, very straightforward. So you use the read_csv method, and it is a very intuitive function name, and you say pd.read_csv and give the path of the file, CSV file. That's about it. And then that is read into the data frame df. This can be any name. We are calling it df. You can call xyz, anything. There's a name, just the name of the object. So head is one of the methods within the data frame, and it will give us the first 5. So this is just to take a quick look. Now you have imported the data. You want to initially have a quick look how your data is looking. What are the values in some of the columns and so on and so forth, right? So typically you would do a head, df.head, to get the sample of, let's say, the first few lines of your data. So that's what has happened here. So it displays the first few lines, and then you can see what are the columns within that, and what are the values in each of these cells, and so on and so forth. You can also, typically you would like to see if there are any null values, or are there any, is the data for whatever reason is invalid or looking dirty for whatever reason, some unnecessary character. So this will give a quick view of that. So in this case, pretty much everything looks okay. Then the next step is to understand the data a little bit overall for each of the columns. What is the information? So the describe function will basically give us a summary of the data. What else can we do? Pandas also allows us to visualize the data, and this is more like a part of what we call it as univariate analysis. That means each and every column you can take and do some plots and visualization to understand data in each of the columns. So for example, here the loan amount column we can take, and then the hist method will create a histogram. So you take all the values from one column, which is loan amount, and you create a histogram to see how the data is distributed, right? So that's what is happening here. And as you can see, there are some extreme values. So this is again to identify, do we have to do some data preparation? Because if the data is in a completely haphazard way, the analysis may be difficult. So these are the initial or exploratory data analysis is primarily done to understand that and see if we need to do some data preparation before we get into the other steps like machine learning and statistical modeling and so on. So in this case, we will see that here by plotting this histogram, we see that there are some extreme values. So there are some values, a lot of it is around 100 range, but there is also something, one or two observations in the 700 range. So it's pretty scattered in that sense, or they're not really scattered, distributedly scattered, but it is randomly scattered. So the range is really huge. So what can we do about this? So there are some steps that we need to do, normalization and so on. So we'll see that in a bit. So this is for one of the columns. Let's take another column, which is applicant income. Similar situation. You have most of your observations in this range, but there are also some which are far off from where most of the observations are. So this is also this also has some extreme values. So we'll have to see what can be done. Credit history is the binary value. So some people have a 0 value and some will have credit history of 1. This is just like a flag. So this basically is telling us how many people have a 1 and how many people have 0. So it looks like majority of them have a value of 1 and a few, about 100 of them, have a value of 0. Okay, what else can we do? So we now understood a little bit about the data. So we need to do some data wrangling or data munging and see if we can bring in some kind of normalization of all this data. And we will kind of try to understand what is data wrangling and before we actually go into it. Okay, so data wrangling is nothing but a process of cleaning the data. If let's say there are multiple things that can happen. In this particular example, there were no missing values, but typically when you get some data, very often it will so happen that a lot of values are missing. Either they are null values or there are a lot of zeros. Now you cannot use such data as it is to perform some, let's say, predictive analysis or perform some machine learning activities and so on. So that is one part of it. So you need to clean the data. The other is unifying the data. Now, these ranges of this data are very huge. Some of them are going from, some columns are going from 0 to 100,000 and some columns are just between 10 to 20 and so on. These will affect the accuracy of the analysis. So we need to do some kind of unifying the data and so on. So that is what data wrangling is all about. So before we actually perform any analysis, we need to bring the data to some kind of a shape so that we can perform additional analysis, actual analysis on this and get some insights. Now, how do we deal with missing values? This is a very common issue when we take data or when we get data from the business, when a data scientist gets the data from the business. So we should never assume that all our data will be clean and all the values filled up and so on, because in real life, very often the data will be dirty. So data wrangling is the process where you kind of clean up the data. First of all, identify whether the data is dirty and then clean up. So how do we find some data is missing? So there are a few ways. You can write a small piece of code which will identify if for a given column or for a given row, any of the observations are null primarily. So this line of code, for example, is doing that. It is trying to identify how many null values or missing values are there for each of the columns. So this is a lambda function, and what we are saying is find out if a value is null and then you add all of them. How many observations are there where this particular column is null. So it does that for all the columns. So here you will see that for loan ID, obviously it's an ID, so there are no null values or missing values. Gender has about 13 observations where the values are missing. Similarly, marital status has 3 and so on and so forth. So we'll see here, for example, loan amount has 21 observations where the values are missing. Loan amount term has 14 observations and so on. So we'll see how to handle this missing values. So there are multiple ways in which you can handle missing values. If the number of observations are very small compared to the total number of observations, then sometimes one of the easy ways is to completely remove that data. So or delete that record, exclude that record. So that is one way of doing it. So if there are, let's say, 1,000,000 records and maybe 10 records are having missing values, it may not be worth doing something to fill up those values. It may be better off to get rid of those observations, right? So that is the missing values are proportionately very small. But if there are relatively large number of missing values, if you exclude those observations, then your accuracy may not be that very good. So the other way of doing it is we can take a mean value for a particular column and fill up wherever there are missing values, fill up those observations or cells with the mean value. So that way what happens is you don't give some value which is too high or too low, and it somehow fits within the range of the observations that we are seeing. So this is one technique. Again, it can be case to case, and you may have to take a call based on your specific situation, but these are some of the common methods. If you see in the previous case, loan amount had 21, and now we went ahead and filled all of those with the mean value. So now there are 0 with missing values. Okay, so this is one part of a data wrangling activity. What else you can do? You can also check what are the types of the data. So df.dtypes will give us what are the various data types. So all right. So you can also perform some basic mathematical observations. We have already seen that mean we found out. So similarly, if you do call the mean method for the data frame object, it will actually perform or display or calculate the mean for pretty much all the numerical columns that are available in this, right? So for example, here applicant income, co-applicant income, and all these are numerical values. So it will display the mean values of all of those. Now, another thing that you can do is you can actually also combine data frames. So let's say you import data from one CSV file into one data frame and another CSV file into another data frame, and then you want to merge these because you want to do an analysis on the entire data. Okay, one example could be that you have data in the form of CSV files, one CSV file for each month of the year, January, February, March, each of these are in a different. So you can import them into, let's say, 12 data frames, and then you can merge them together as a single data frame, and then you perform your analysis on the entire data frame or the entire data for the year. So that is one example. So how do we do that? This is how we do. Again, in this case, we are not importing any data. We are just creating some random values using some random values. So let's assume I have a data frame which is by the name 1, and I assign some random values here, which is a 5x4 format. So there are 5 rows and 4 columns, and this is how my data frame 1 looks. And then I create another data frame, which is data frame 2, again random numbers of the format 5x4, and I have something like this. Now I want to combine these two. How do I combine these two? I can use the concatenate or concat method, and I can combine these two. So pd.concat, and it takes the data frames 1 and 2. If you have more of them, you can provide them, and it will just simply add all of them, merge all of them, or concatenate, whatever you call, whichever term you call, it will. So of course we have to make sure that the structure remains the same. Like I said, this could be, let's say, sales data coming for 12 different months, but each of the files has the same structure. So now you can combine all of them, merge all of them using the concat method. If we have, let's say, structure is not identical, then what will happen? Let's say we have these two data frames. One has a column by the name key and the second column is lval, and a second data frame which has a column by the name key, but the second column by the name rval, not lval. So you see here the structure is not identical. So you can still combine them, but then the way they get combined or merged is somewhat like this. So it takes the key as a common parameter between them. Some common column has to be there, otherwise this will not work. And then we have to use merge instead of concatenate. And when we do a merge, then we get the result will be in this format. What it does is it uses the key as a common thread between them, and then it kind of populates the values accordingly. So if you see here, the first one had foo and bar for key, and then it had L values of 1 and 2, right? So if we go back, foo and bar had 1 and 2 L values. So that's what we see here, 1 and 2. Whereas in the right data frame, we had foo, bar and bar as a second time, and then R values are 3, 4 and 5. So what it has done for foo, it has put for the existing, right? For foo is already existing because it has come from left. So it will just put the value of R val here, which is 3. Similarly, it will put 4 here because for bar, if you go back, for bar it is the value is 4. And since it has one more value of bar, it will go and add this 5 as well. The only thing here is that this one had, for example, left had only 2 values and only 1 value for bar. But since we are appending or merging, and there are 2 key values with the bar, therefore it will kind of repeat the value of lval here. So that's what we are seeing in this case, right? So L value appears twice, the number 2 appears twice, but that is because R value, there are 2 of them. Okay. All right. So that is how, when you don't have identical structure, that is how you merge.
What's really going on in your data? That's what descriptive analysis helps answer. In this section, we will explore key metrics like average, variance, and trends, giving you big picture and the fine details, all from the data you already have. Now let's shift gears to data analysis techniques, starting with descriptive analysis. This is the foundation step where we aim to summarize and describe the main features of our dataset. Think of it as getting a general overview before we dive into more complex analysis. We use techniques to find things like typical values, how spread our data is, and overall shape of the data distribution. This helps us get basic understanding of what our data looks like. The initial exploration is crucial for formulating further questions and choosing more advanced analytical methods. Within descriptive analysis, one important concept is dispersion, which is all about understanding how spread our data points are. We looked at a few key measures here. The range simply tells us difference between the highest and the lowest value. Variance gives us a more detailed measure of the overall variability by looking at the average and the square difference from the average. And standard deviation, which is square root of the variance, gives an even more interpretable idea of how much data typically deviates from the average. Understanding dispersion is vital because it tells us about the variability and consistency within our data. Another key part of descriptive analysis is central tendency, which focuses on identifying the typical or average value of our data. We have few common ways to do this. The mean is a standard arithmetic average, but it can be influenced by extreme values, and medium is middle value when the data is ordered and is less affected by these extremes. The mode is simply the value that appears most often, and while average is more used interchangeably with mean, it can sometimes refers to any of these measures. Choosing the right measure of central tendency depends on the nature of our data and what we want to highlight. Finally, we are describing the shape of our data. We often look at skewness and kurtosis. Skewness tells about a asymmetric of the data. A positive skew means tail extends to the right, and a negative skew means extends to the left, and zero skew means it's symmetrical. Kurtosis, on other hand, describes the tailness and peakness of the distribution compared to normal distribution. High kurtosis means the sharper the peak, the heavier tails. How kurtosis means a flattened peak and thinner tails, and mesocrit is similar to a normal distribution. These shape characteristics can provide valuable insights into the underlying pattern and potential outlier within our data. Number tells story, but visuals bring it to life. In this section, you will learn how to turn raw data into compelling charts and dashboards. From Tableau to Power BI, we'll cover tools that help your audience understand the data at a glance.
We will start by learning how to create reports and dashboards using Tableau. Tableau is a powerful business intelligence and data visualization software that is popularly used in several industries. Then, we will learn another important data visualization tool, that is Power BI. You will learn how to create charts and graphs in Power BI Desktop and publish reports on Power BI Service. Moving ahead, we will learn to create an Excel dashboard where we will see how to create reports using sales data. Then, we will see how to use important visualization packages in R to build different charts and graphs. So we will learn about ggplot and plotly packages. Finally, we will look at the important data visualization package in Python, that is matplotlib. So let's get started.
Hello and welcome to Tableau Training for Beginners. My name is Michelle Covine and I'm with the Simplilearn team. Today we'll be talking about all the things you need to know to get started with Tableau. So here's our agenda. We'll be talking about business intelligence and why it's important, and some BI tools. Then we'll talk about Tableau and why we use Tableau for business intelligence, and do a quick overview of Tableau installation. Then we'll show you how you can get started by connecting to data, and we'll do an overview of the Tableau workspace. We'll go a little bit deeper into the Tableau workspace as we look at worksheets and dashboards, and we show you how you can ask questions using visualizations. We'll look at hierarchy and drill down, calculated fields. We'll look at parameters and sets, and finally we'll show you how to build a donut chart and a 2D pie chart. So what is business intelligence? Companies use business intelligence technologies to collect, analyze, and present data in order to create actionable information. Today's businesses are always seeking insights about their customers, products, and services. So businesses are faced with many questions, such as how do I know my customers are happy? What would make my customers stay? And how can I increase awareness of my products and services? Business intelligence can help you answer those questions. When you have a question about what your customers are feeling, what your customers are doing, who the customers are, and what's the best channel to target them, business intelligence is a method of transforming your data into these insights and measurable metrics. Business intelligence tools are designed to make the data flow manageable. In the age of information, Tableau is one of many tools to help manage the data flow and turn data into actionable information. We also have Qlik and SAP and Oracle. You may have heard of some of these. Let's take a look at some of the benefits of Tableau as your business intelligence tool. So why would we use Tableau? It can be connected to 40 different data sources. The more data sources it can connect to, it means that you are more likely to get direct access to your data. It can build interactive dashboards with just a few clicks, which can help you quickly understand your data, and it lets you see your outliers. There's also simple analytics built right into Tableau, such as trends and forecasting, that can help you understand your data on a deeper level. Tableau has been a leader in the Gartner Magic Quadrant for the last 6 years, and that includes 2018. Here we will take a look at an overview of the products offered by Tableau. So we have Tableau Desktop, which is where you do all of your development. This is where you connect to and build visualizations and dashboards. Today we'll be using Tableau Public, which is a free version of Tableau Desktop, but with some limitations, such as having no R integration, and it can only support up to 1 million rows of data. Also, any data published here is made public, so you can't use this for private company information. Then there's a new tool called Tableau Prep, where you can prepare your data by seeing it visually before you connect and build reports. There's also Tableau Online, which is a cloud-hosted version of Tableau Server, a place where you can publish your dashboards, and it enables you to share your dashboards in a secure way. Tableau Server has an option to be on-premises. So let's just do a quick comparison between building a visualization in Excel and building one in Tableau. Okay, so here we have an Excel file full of data that we will soon connect to and use for some of our demonstration purposes. And you can see that we have information about orders. If we wanted to find out the quantity sold and the sum of sales for each region, we could do that by creating a pivot table. So we'll make it, I selected my cells, we'll make it in a new worksheet. And here we have the beginnings of a pivot chart. And we can grab region and pull it into our columns. And then we'll grab sales and put it into values. And then we also want to look at quantity and put that into values. And it's automatically summing up sales and quantity, but you can choose if you want it to be sum or not. And then we'll take our values and put it on rows so that we can see sales and quantity one on top of the other. And that's the basics of a pivot chart. Now let's do a similar thing in Tableau. Okay, so we have our connection to the data, and Tableau automatically splits out the dimensions from the measures. We'll go into more depth on that later. But we can come and grab region and put it onto columns, and we get a similar thing, maybe a little nicer formatted. And then we can come and put quantity there. And if we want to add sales to it, we can double click on sales, and we'll have quantity and sales one on top of the other. We can put sales on top by dragging quantity down in that box. We also have this show me dialog box, which allows you to see what visualizations you could build using what's already on the screen or the things that you have selected. So right now, we could quickly switch it to bar charts, and now we can see quantity and sales across our region with bar charts, or we could switch it to stacked bars, and we can see our quantity across the regions. If you close that, we can see our legend over here, and then our sales across the region. So in Tableau, we have a lot of really quick flexibility to turn just text into a visualization. So in summary, we can see a side-by-side of what we made using pivot tables in Excel and what we made in a similar amount of time in Tableau. Let's get started with the Tableau installation. As for requirements, you need Windows 7 or later, or you need your Mac operating system to be 10.11 or later. Here are some of the browsers you can use to install Tableau. We will be installing Tableau Public today, and to do that, you just Google Tableau Public Download and click on that first link, and then you put in your email address and click download the app. So let's just look up Tableau Public Download, and it's this first one. You can click download now, and it takes you to the Tableau Public page where you can click sign in and create an account free. This gives you a place to save the visualizations you make, but keep in mind anything you save on Tableau Public is public. And then you come here and you enter your email address and click download the app, and it should give you an executable file that you will download. And once it's downloaded, you should be able to open Tableau Public. So let's go take a look at the Tableau Public opening page. So this is what Tableau Public looks like when you first open it. On your left, you have the different things you can connect to. This is more limited in Tableau Public than it is in Tableau Desktop. So if you invest in Tableau Desktop, you have many things you can connect to. You can also connect to data by clicking this drop-down Connect Data piece. That's especially useful when you've already started your visualization. Then we have this central portion called Open. This is where anything that you have opened up previously will show up. You can also click Open from Tableau Public, and when you have, my connection's timed out so I need to log in, but when you log in, it says no workbooks found, try publishing first. This is where you'll see all of your published Tableau Public dashboards. Over here we have Discover, and it has some how-to videos, visualization of the day, which is where people who have made Tableau Public visualizations get recognized for their skill, and you get some pretty cool ideas when you look there. So let's get started by connecting to a data source. We'll click Microsoft Excel, and we'll choose our Excel file and open it up. And this is our data source page. This shows you the sheets on the Excel file and allows you to drag them in so that you can see the data show up. This gives you a preview of what your data will look like. You can see that Tableau is starting to classify our fields. So anything that has ABC on it shows that that's a column that has strings in it. We also have a globe, which was where Tableau has recognized these values to be geographical. So we have state, and it's recognized that it contains states. It bases it on the keywords that it stores to identify if it's geographical. And so it takes a look, and you've named it city, and it knows that city is geographical. We also have the calendar symbol, where it's recognized that it's a date field. And we also have row ID that shows up with the hashtag, and it recognizes it's a number. So now that we have our data source pulled in, we can come here and hit Sheet, which is where you start to build your visualization. Let's take a look at all the different pieces of this before we go any further. We have the data that we're connected to up here. It's our orders sheet from the Sample Superstore Excel sheet. We have dimensions on top and measures on bottom. These are where we're going to get the fields to drag and drop. Here we have our cards. We'll look more in depth at our cards in a moment. And these are our shelves, the column shelf and the row shelf, where you can drag things in to make changes happen in the visualization center. We have our Show Me tabs, where you can see, we took a brief look at this earlier, but you can see all of the different visualizations you can build here. A neat thing about Show Me is that when you hover, it'll tell you what types of fields you need to build it. So for a symbol map, try 1 geographical field, 0 or more dimensions, or 0 to 2 measures. And that's how you can build a geographical symbol map. And when you're done with Show Me, you just close it. Let's take a look here at our sheets. So we have Sheet 1 and Sheet 2. A sheet is basically just one visualization at a time. Let's get rid of the extra sheet. We have a dashboard, which is where you can pull multiple sheets on to show multiple visualizations at one time. And then we have what's called a story, which allows you to show a sequence of visualizations so that you can tell a story. Perfect. Okay, so we saw that Tableau is categorizing our different fields, and it is also giving it a role. So we have dimensions on top and measures on bottom. Dimensions contain descriptive values, such as names, dates, and geographical data. You can use dimensions to reveal details in your data, that is, qualitative details. We also have measures, which contain numeric, quantitative values that you can measure. Measures can be aggregated, and when you drag a measure onto the view, Tableau will apply an aggregation to that measure. It's sum by default. So let's show this by building what we built before. We'll grab region, and we'll see its 4 distinct values as a dimension. And then we'll double click on quantity, and we can see the numbers here, the measures, and you can see here that it is the sum of quantity. And now we can also double click on sales, and we can see quantity and sales. To discuss a little bit more about dimensions and measures, you can see that in general measures are numbers and dimensions are not. But sometimes, like row ID, it is a number. Now, why would we have a number up here instead of in the measures? So you can tell the difference between a number, whether it should be in measures or it should be in dimensions, based on whether you'll need to do any calculations on it, or if you would want to be able to aggregate it at some time. So for sales, if you have several orders in a day, you might want to know what the sum of those sales are. But if you have several orders in the day, and they're on rows 2, 3, 4, and 5, you might not want to know the sum of the rows. So Tableau is smart enough that when it sees ID, it knows that it belongs up in the dimensions. Now you can switch. So if row ID was actually something you would want to aggregate for some reason, you can drag it down to the measures and add it down there. But in our case, row ID isn't something that you want to sum or average. Can you think of any other numbers that might not show up as a measure that should be a dimension? Comment below with your answers. as we discussed before, dimensions are on top, measures are on bottom, and you can see the blue is associated with dimensions and green is associated with measures. But it's a little bit more complicated than that. So dimensions are qualitative and measures are quantitative, but blue means we want our label to be discrete and green means we want our label to be continuous. Let's make a new sheet and make a visualization to kind of show this. So we can bring on quantity and we're going to use it as a dimension, but you can see even when it's a dimension you can choose continuous or discrete. So right now it's a dimension but it's green. It's a little bit different than what you might expect. And then we'll do sales. So now we can see over the different quantities what our sales was. Has been for this period of time that we're looking at. I believe it's 4 years. So for when people bought 3 items, the total sales was that number. And you can see that this is an axis. So it's from 1 to 15. Now, if we change it from continuous to discrete, you can see that 1 is a label, 2 is a label, and it's not an axis ranging from 1 to, it doesn't even have 15 because there are no values under 15. These are just individual labels. So we go back, it's green again, and you can see that it's an axis. So we have 2 greens on here, so we have 2 axes. And change it back to discrete, and now we have 1 axis and 1 set of individual labels. So let's go back to our sheet 3. We have all of these different sales by the different quantity numbers, and up here we have our sorting. When you hover, it tells you what kind of sorting is going to happen. So we could sort quantity descending by sales. So we can see that when they buy 3 things, we have the highest sales. You can do the opposite, where it's the lowest to the highest number of sales. You can also do sorting more in depth by clicking on the quantity and right-clicking sort. So we could just sort by descending or ascending or by sales or alphabetic, which is not what we want. You can choose the field or you can manually change your sorting here. And now we're back to what we had at the beginning. Now that we've had an overview of how Tableau works, let's go into a little more detail. Tableau is very much built on the premise of drag and drop. So let's build a simple visualization and talk about what each of these shelves and marks cards specifically do. So we're going to make a simple chart which is average sales by region. So we know we want sales on, let's do sales on rows. Now for rows and for metrics, since this is continuous like we talked about before, it's making an axis for our sales. We also can drag region onto columns, and it makes 1 column per region. So that's how it works with dimensions. If you pull a dimension onto columns, you're saying I want 1 blank per column. I want 1 region per column. So if you wanted to do it by instead of region, if you want to remove something from a visualization, you just pull it back off. Or you can hit undo or Control Z. Tableau has the benefit of having unlimited undos. So let's say we wanted to bring on city. Let's say we want 1 column per city. And that's what you get. And there's a lot of cities. So that's what it looks like. Let's take city back off. I want 1 column per region. And for sales, I want my rows axes to show me where sales are. Great. Now, let's say we want to adjust the color of these bars. You can click on color, and you can select any of them. So let's pick this nice blue, or we can pick an orange, and that's how you can determine the color. But if you want something else to determine the color, you can take region and drag it onto color, and now we have 1 color per region. Now with measures, again, since they're continuous, it's going to be more like a scale. So if I want them to be a different color based on sales, and I pull sales onto color, it's going to be darker where there's higher sales and lighter where there's lower sales. So it's continuous from light to dark. But for region, it is one color per region. So they're distinct colors. It's not continuous. Great. Let's say we want to sort this biggest to smallest, and we can look at size here. So if we want to adjust the size manually, we can click on it and drag it. But if we want the size to be based on something else, you choose a measure for the size. So if we want it to be wider based on sales, we will drag sales onto size, and we can see that it gets bigger with bigger sales. We can do the same thing and replace the sales with profit, and now it's bigger if there is bigger profit. And drag that back off. So you can determine manually, or you can do it with your measures. For label, let's say we want the sales onto label. Now we can see the exact sales number for each region. What if we wanted the name of the region there as well? We can drag region onto labels, and we can see sales for the West region. You can adjust which one goes on top. See how we have two T's here? Those are both labels. Great. Tooltip. When we click on tooltip, it'll show us what's going to happen when we hover. So as I hover here on East, it says region East sales, and then it shows the sales amount. Now we talked about, I'll take my labels back off, wanting to make this visualization not for the sum of sales, but for the average of sales. So we will right click on our sum of sales here in the rows, hover over measure, which right now is sum, and change it to average. And we have a different result here. So let's sort again, and we can see that the South region actually has the highest average of sales, which was not the case for the sum. Now let's say we want our sales to be on the label, but look, it's giving us the sum of sales label. So we just do the same thing and change it to average. Now we can see our average on the label. The label has some interesting options, like you can format this, and we could say maybe we want it to be all of them to be blue, and that happens right there. You can also choose to only show the minimum and the maximum. This becomes handy on a line chart where you don't want all marks labeled because it gets very messy, but you want the tallest and the shortest part to be labeled. And maybe you just want the tallest, so we'll click label minimum value and remove that checkbox, and now we just have the tallest value there. And one card that we haven't used yet is the filters card. So we could allow people to look at this, but only certain regions. So what we can do is we can come over to region and right click on it and click show filter, and it will add it to that filters card. And now we can remove central from the mix and just look at those ones. You see, if we remove South, the new highest, East, now has the label, but if we put it back in, South will have the label again. If we don't want to have these filters, we can pull it off there. Or if we wanted to filter out by country, we just have United States. So let's not filter by country. But we could pull in category, and we have these filters by category. If we select them all, they'll all be there. And we click show filter, and it will bring it over here. And we can remove out technology, and the South still has the highest for the other two. But if we only include technology, you can see the difference there. So that's the basics of filters. Another thing that I can mention here is that you can change the type of mark manually. So you saw when we pulled on region and we pulled on sales, it automatically made us a bar chart. But we could change this to be a line chart, and you can see that the color changes because we told it to based on region. If we pull that off, then it would be a line chart there. You can change it to be a lot of different type of visualizations here. So when you're not using show me to help determine your graphs, you can choose it manually right here. Okay, Now let's look at building a scatter plot. So a scatter plot is when you have a bunch of shapes and points on a visualization with two axes that are both measures. So if we take sales and put it on the y-axis, and we take discount and put it on the x-axis, we can see our point that represents all of our data with the sum of sales and the sum of discount. And if we wanted to see this per order, we'll take order ID and put it onto detail. Now what detail does is it determines the level that we are building our visualization at. So grabbing order ID and putting onto detail gives us all of these little points. So for each order, what was our sales and what was our discount? So we have out here some outliers that you can find very quickly. Let's actually do product ID instead. So I'll put it right over top of order ID and it will replace it. Now we see all of our products. Anything that has high sales is up here, anything that has high discount is over here. You can see that it sort of has a trend where things with high sales do not have high discounts, which makes sense. If we wanted to know what category these products all show up in, we could take category and put it onto shape. And now we have 3 different shapes that tell us the categories. Tableau has a cool new highlight feature, which allows you to show just the dimension that you want to see, but it leaves the other ones in place. So for example, if we click on furniture, first we have to turn on the highlight feature, and then click on furniture. And now you can see all of the furniture items popping up in our visualization and how they're kind of clustered in this area and the pattern for them. When we click on technology, we can see their pattern, which is a little bit different. So we have them by shape with category. Let's drag category onto color as well. If you remember, category will determine the color and the shape at this point. And so we can kind of see the patterns happening there. So if we want to see our high discounted items, they're all over here. And most of the things that are getting high discounts are office supplies, which is interesting. And then our highest sales product up here, now we could take that product ID and find out what that product actually is out of our, oh, look, we have product name. Let's replace product ID with product name. And we see that that is a Canon Image Class Advanced Copier. So this copier is our big salesperson. And office supplies binders do not give us very many sales, and we're highly discounting them. So now you know a little bit more about the details card and the shapes card, and about using highlighting in Tableau. So let's say we wanted to know by subcategory what our profit is like. We could grab subcategory and pull it onto columns, and we would say we want 1 column per subcategory. And then let's grab profit and pull it onto rows, and you can quickly see which categories are profitable and which ones are not. So we can also take profit and put it onto color so that you can see that even more clearly. Right now it is going from orange to blue, which is Tableau's default. If we wanted to change from what color to what color it was going, we have a lot of options in here when you go to edit colors. So maybe you wanted to go from red to blue, just to emphasize that the profit that's negative is bad. So we can hit apply, and now we can see red to blue. We have our categories here, our subcategories here, but let's separate it out by category. So what I'm going to do, I'm going to take subcategory off. I'm going to put on category, and now it's by category, and then I'm going to put subcategory on after it. So when we put it in order like this, the order matters in Tableau. So first it breaks it up by category, and then inside of that it breaks it up by subcategory. So furniture's all here, and then there's our subcategories under furniture. If we were to move subcategory to the front, it really doesn't group it appropriately, because first it's breaking it up by subcategory and then by category, and that's not effective. We end up with furniture, 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 furniture spread out across our visualization. So again, let's put category to the front. And now we have our profit by category by subcategory. And we can click sort subcategory descending by profit. And now what it does is within the highest group, within each group, it then sorts it by profit. So you can tell it's not going to break this group apart to move tables to the very end. It's going to keep tables inside of furniture. And then it doesn't move furniture to the very end either. So what we have here is a quick view by subcategory how we're doing on profit. We can see that tables is our biggest drain on profit. And so if we wanted to improve the profitability of furniture, maybe we would not sell tables anymore. It's just not working out for us. Another thing about this visualization that we could do to improve it is you can see that there's some of these words are getting cut off. So we could right click on this axis and click rotate label. And now you can read the whole word. And so that's helpful. Also up here we have our title, which right now is the same name as our sheet. So if we rename the sheet to profit by subcategory, then it names the title up here. So this is making it look a little bit better. And then here we have profit, and it shows it, but without any like dollar signs. So let's come up here to profit and click format, and you can see that we can format the sum of profit to be currency. And we can do it currency by the thousands, and we can get rid of these decimal places. And now you can see it's just a little bit nicer, a little bit more clear. Maybe we don't have to have the label here that says category / subcategory. So we can hide field labels for columns, because it's pretty clear that these are categories and these are subcategories. So those are some formatting tips for you. Formatting in Tableau is one of those things where there are just a lot of different ways you could change things. So in more in-depth videos, especially from Simplilearn, you'll learn more and more about this. Also, as we are building these visualizations, if you want to have access to this data set so that you can build along with me, just make a comment in the comments below and the Simplilearn team will send you this data set. Now we're going to take a look at creating a hierarchy in Tableau. So we'll make a new tab, and we're going to make a sheet called Sales by Product. And so we will be looking at sales as a number. And let's bring on product name. Now there are a lot of products names, so it's going to make sure that you really want to do this. I'm going to click add all members, and now we can see all of our products and their sales over all time. So if we sort this, we can see our highest selling item, which we discovered earlier as the advanced copier, and we scroll down to the bottom, our lowest selling items. So we have our products, and we can group that by subcategory. And you can see I need to put it in the front again. And by category. Alright, I'm going to take product name back off, and we're going to talk about hierarchies. So, a product rolls up into a subcategory, which rolls up into a category. You can create a hierarchy by, let's start with subcategory and dragging it onto category. And it's going to create a hierarchy. We'll call it our product hierarchy. And now it knows that category is the parent to subcategory. Let's do the same thing by grabbing the product name and putting it underneath subcategory. So now it knows category is the parent, then there's subcategory, and then there's product name. This allows you to, instead of pulling this off or putting it back on, you can bring category on, and then you can expand it by pressing this plus button. And now we see, but here's our sales by category, by subcategory. And then here's our sales by category, by subcategory, by product name. This is really useful when you're creating a detail section for your users. And so when somebody wants to know, let's say you have show filter for category and a filter for subcategory, show filter for subcategory, and they're looking at category here and they're just like, I see technology has the highest sales and I just want to see technology. So I'm going to unclick furniture and office supplies. Let's put category on top. And then, so I just have technology. Well, I want to see what has the highest sales inside of technology. And let's sort it. Oh, phones. Phones does. So I just actually want to look at phones. So I'm going to remove accessories, copiers, and machines. And what has the highest sales inside of phones? And sort it. And now I can see quickly the detailed information without having to change my visualization. Let's give this visualization a little more depth. First, I'll add back in all of our categories and subcategories by showing across region. So we know technology had the highest, but how does it look across region? Now, part of the point of Tableau is to allow the users to read the visualizations very quickly. And when you have big blocks of text like this, it's kind of hard to see which one has the highest because it doesn't quite stand out very quickly. So what we can do is take sales and drag it onto color. Let's change our marks to a square, and now it's going to color each of these. It colors every one of these cells based on its darkness for sales. This is a little bit heavy of a color. You can click color here and change the opacity to give it a little bit of a lighter look. Just makes it a little bit see-through. Great, so now it's a lot easier to see that the West seems to have the highest sales and that technology in the East is the very highest. So now when we drill into subcategory, it keeps that coloring and we can see more in depth and quicker that phones has the highest across most of them. It's not quite the highest in the West because chairs is the highest in the West. There's one place in Tableau where hierarchies are built in, and that's in dates. So dates in Tableau can be very complex because they allow very complex visualizations. So we will not go into depth about dates at this time, but let's take a look at how they work for hierarchies. So we have order date that we can pull onto columns here. And you can see that it's blue, meaning that it's discrete. So each one of these is a header instead of it being an axis across the top. Now let's drag profit onto rows. So now we can see our profit over time for each of these years. And Tableau has some hierarchies built into dates already. So when I click this plus on columns, it'll split it out into quarters. So this is a header, and these are all subheaders underneath that header because it is distinct and discrete right now instead of continuous. So it's split out year, 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 and quarters, 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 quarters. This allows you to quickly compare quarter 1 across all of the years, and quarter 2 across all of the years, and quarter 4 across all of the years. Another way you could add some more detail to this is by taking maybe category and pulling it onto color. And now we have one line for each category. And we can see that drop in technology is a big part of the responsibility for that drop we were seeing in quarter 2 of 2016. So let's take that back off, and let's take quarter back off, and let's explore continuous dates. So here in dates, we have our top section of dates, and then you see it repeats, and we have the bottom section of dates. So we've got year, but we also have year here, quarter, and quarter. Now the top ones are all discrete, and when I change it to a bottom one, year, same thing, same year, it changes it to be green, and now it's continuous. So now instead of this being a header for 2013 and a header for 2014, it's an axis. So the difference here is when I press the plus and it changes it to quarter. Instead of adding quarter to year, now it's doing quarter for each year and making one continuous line. And we can keep going and drill down to month. You can go pretty far. Now when we add category as color, we get our 3 lines for the 3 categories. And we also have highlighting turned on here still, so when we click on technology, we can highlight technology with the others in the background, so we don't lose the context of the other categories. Let's take that back off. Next, let us talk about calculated fields. So we'll make a new sheet, and we're going to create our first calculated field. We can create a calculated field by clicking this arrow, which gives us some options, and clicking Create Calculated Field, or we can come and click in the white space below dimensions or below measures, and we right click and click Create Calculated Field. Let's name it Profit Ratio. So this is for if we wanted to create a visualization that showed the profit ratio, but we don't have that measure readily available to us. To bring in fields for our calculation, you can do it in one of 2 ways. One is to start typing it, and it will start auto-prompting you for the different measures or for different calculations or values you can use, or you can come and drag it in. So if we want profit and we want sales, and if we do profit divided by sales, that is our profit ratio unaggregated. Okay, and let's make a second calculated field. We could come here and click duplicate, and that will duplicate our field, but I just want to start over again, so I'll click Create Calculated Field, and I will call it Profit Ratio Aggregated. And in this one, we're going to do sum, click, of profit, click, divided by sum of sales. Okay, so now, what's the difference between profit ratio aggregated and profit ratio unaggregated? How will those behave differently in Tableau? Let's look at this by looking at a single order. So first, let's bring on all the orders and all the products under that order. And let's look at this order. So I want to filter this whole dashboard to only this order. So I can right click on it and click Keep Only. That creates a filter up here that only has that box checked. And if I want to get rid of this later, I can just pull it right off of filters and everything will come back. But I want to, so keep only. And now let's take a look at profit ratio aggregated. I double clicked on it and I added it here, and profit ratio unaggregated. Again, double clicking, and now they're side by side. Let's give us a little bit of more room. So when I dragged that out, it gave us more room so we could see them side by side in the entire titles. Okay, so I chose to look at one order and these product names because the combination of order and product name is unique, one per row. We know that Tableau will aggregate the data up to the lowest level in the visualization, and I brought it all the way down to the lowest level of the data source, so we have no aggregation right now. So when we're looking at it without any aggregation, these two calculations are the same. Profit ratio aggregated, let's look at that again. We'll click Edit, and that's the one where we sum profit and sum sales before we divide. And then we've got profit ratio unaggregated. So let's also look at profit and look at sales. This is a technique that I use when I'm trying to understand how my calculated fields are working. Try to break it down to the lowest level possible and see if it's doing what I expect. So we've got profit and we've got sales. Now, both of them are at 0.5 or 50%, and that's because profit is 8 and sales is 16 for Adam's telephone messaging. Now, let's take off product name. When we take off product name, we can see that they start to vary. We've got profit ratio aggregated and profit ratio unaggregated. So here we have profit and sales. The profit ratio should be profit divided by sales. So let's open up a calculator and make it a little smaller. So if we take profit at 219.1 and divide it by sales at 508.6, we get 0.4, not 1.8. So where does this 1.8 come from? Well, let's put product name back on here. What happens is, with profit ratio aggregated, it sums up the profit and then divides it by the sum of sales. So that's what we did. When we took off profit ratio unaggregated, we had the sum of profit and divided it by the sum of sales, which is what we want. Profit ratio unaggregated, however, does the calculation, profit divided by sales, and then sums it afterwards. You can see it right here. It's the sum of profit ratio unaggregated. So it makes this calculation, and then it adds up 0.5 plus 0.5 plus 0.3 plus 0.5. And that's where we get our 1.8, which is what we see when we pull off product name, 1.8. So for most calculations, you want to do profit ratio aggregated, where you determine how it's aggregated before you do the calculation. So let's remove profit ratio unaggregated and delete it. Let's go to profit ratio aggregated and just call it profit ratio. Perfect. Now we no longer need anything that we have on our visualization right now, so let me show you a quick trick to clear the board. Tableau has this button up here, which is called Clear Sheet. You can also do on Windows Alt-Shift-Backspace, and you just click Clear Sheet, and it will start you over with that sheet. And that really helps when you've dragged a bunch of things on and really made a mess when you're trying things out. Okay, so we're going to build a visualization, and we're going to look at region, and we're going to look at it by profit ratio. And so now we have this bar chart by profit ratio. Let's color this by region. We can also pull on profit and sales, and we can see all three of them side by side, split out by region. Now let's say we also wanted to see each region by sales per customer. So let's create some calculated fields that will help us do that. Let's create our first calculated field that's going to get us a count of customers. Let's call it total number of customers. And so we have customer name and customer ID. Let's do count distinct of customer ID. And that gives us the total number of customers. Apply. So right now, we could take total number of customers and see which categories have the highest number of customers. Perfect, but that's just one part of our calculation. We want to see total sales divided by total number of customers. So let's make our second calculated field, and we're going to call it sales per customer. We're going to do our sum of sales, which we can drag in, and divide that by total number of customers. Now you see that calculated field we just made pops up inside of our calculation dialog box. And we hit apply, and it shows up, so we hit OK. And let's replace total number of customers with sales per customer. And now we can see our sales per customer ratio and which ones have the highest. For this next part, I'm going to make a couple of visualizations in a row that all apply to the same information using a couple of different tactics. So first, let's use show me. So I want to look at region and sales for this visualization. So I'm going to control click region after I clicked sales. So one more time, I'm going to click on sales, and I'm going to control click region, and I'm going to click show me. And it's going to give me all of the different visualizations I could make with region and sales. Let's pick tree map. Great, so now we have a tree map that shows us our sales by region. And we have the size and the color of the box is both sales. So let's say we wanted the size to be sales, but the color to be profit. So let's grab profit and drag that onto sales. So now we can see our most profitable to our least profitable. Let's edit our colors, and we're going to change it from red to blue diverging, red to blue. But let's go to advanced and make the center number 0. This means that it will never be red unless it's less than 0. So let's hit apply. So it's all blue, and if anything ever goes negative, then it will be red. Okay, let's call this sheet sales profit by region. Perfect. Now we're going to start using our geographical fields. So we have state, city, country, and postal code. Let's double click on state and see what happens. Awesome. So it is generated these two fields. Tableau has generated longitude and latitude for us, and it's been able to recognize the states in the United States and where they're located and given it a longitude and latitude. So next we will look at sales by state by double clicking on sales, and what it's done was change the size of the dot based on sales. Now I think I'm going to move sales from size to color, and it has automatically changed it to a filled map instead of dots on a map. Perfect. So now we can see the states with the biggest amount of sales. Let's put it back onto size, and we have our circles again. Let's put sales onto size, not state onto size, and we have our circles again. But let's make them a little bit bigger. These two marks on the Tableau size line are to give you an idea of how big and how small you should go before it gets too difficult to see. So when we go bigger than the bigger line, it detects that you're getting close to having overlap. But it's up to you as the builder. Okay, so we have size for sales again, and for profit onto color again. So you can see anything that is more profitable is darker, and anything that is less profitable, or less than 0 in this case, is orange. Let's do what we did with color before. Change it to red, blue diverging, and set our center point to 0. Okay, so now we know that if anything is red, it was negative in profit. Perfect. Let's name this sheet Sales Profit by State. Great. Now let's look at sales and profit by category. So we have category and we've made columns. So this is when we drag something to the columns shelf, just remember we want one column per category. And let's double click on sales, and it's going to put it into text, and that's not what I want. So let's take sales and drag it onto rows, and it automatically makes a bar chart. So now we have one bar with the axis of sales for furniture, office supplies, and technology. Now let's take profit and also put it on rows. So now we have two bar charts, one for sales and one for profit. We can change which one is a bar and which one is maybe a bubble chart by clicking on its appropriate marks card. So if we want to change them both, we can click on all and change them both to maybe circles, and you can see how they go up and down. But if we want to just change one of them, let's put those back to automatic. We'll go to profit and change that one to the circles. So now we can see those profit numbers. And if we want them to be overlaid on the same area, we would right click on profit, the second measure on the rows, and click dual axis. So now let's put them onto the same axis. You can see that their axes are not lined up. Let's go to sales and change it back to a bar. So now we have two charts occupying the same space. One of them is a bar chart and one of them is a bubble chart. And we can see our sales versus our profit. At least they're not the same amount of dollars, obviously, but we can see a higher sales and a higher profit. We also have medium sales and a medium profit. We have a medium sales but a really low profit, and it's interesting to see that contrast. So let's rename this sheet as Sales Profit by Category. And finally, we're going to make our details sheet. So we're going to go down to subcategory level and bring it onto rows. And remember, subcategory can expand out to the actual products. Let's bring that back in. And we're going to bring sales onto columns, which makes us a sales bar chart, and profit onto columns, which makes us a profit bar chart. Now let's color them by their appropriate individual color. So we'll go to the sales marks card and drag sales onto color. Now sales is colored by sales. We'll do the same thing here we did before. We'll go red, blue diverging, and make the center 0. We actually don't have to do that for sales because sales will never be negative, but it's pretty important for profit. So we'll go to the profit marks card and take profit onto color and do the same thing there. We have red, blue diverging, advanced, center is 0. Great. So now if it's negative, it will be there. So let's sort this by profit. And so both of them have sorted with profit in mind. And we can easily see our subcategories that have a negative profit. Let's rename this, and we'll call it our details sheet. So now we have these 4 visualizations that all have to do with similar information. I think I want these bigger on the states, so we'll just keep making that bigger. Perfect. Now we're going to make our first dashboard. So for our dashboard, we have information over here that shows you what sheets you can bring on. These get a little bit more complex, so they'll be covered in more in-depth type of videos. And then we have our size. So we could make a range of sizes based on maybe what you're viewing this on. But we're just going to change it to a fixed size. And we're going to make it 1400 by 1000, and this is our dashboard size. So let's bring on sales profit by region, sales and profit by state. Now a map needs a little bit more horizontal space than region does. Let's bring sales and profit by category underneath the region and the detail underneath the state. Give our map more space again. Perfect. Now Tableau has this neat feature called Uses Filter. So you can click Uses Filter here, and now if I click on any of these, it will filter the other dashboards based on these features. So if I just want to look at the South, and I click on South, it zooms into all my South states. Now my categories have updated to be just the South ones, and my details have updated as well. So we could see that Central has pretty big sales, you know, bigger than the South, but the profit is lower than the South. So we can click on Central and focus on Central. Let's use that Uses Filter on all 3 of these dashboards that lead us up to the detail. So building a quick dashboard like this, let's make this taller, would allow you to do some sort of analysis, such as, let's take a look at Central because they have relatively high profits but low sales. So we click on Central and then we see, oh man, Texas is having a really hard time. So let's click on Texas, and now we're seeing in Texas that we have negative profit in these categories. So we can control click on furniture and office supplies, and we can see all of our products that are really just killing us in Texas, all of our subcategories. And if we want to go deeper into products, we'll just click that plus sign, and now we see all the products, and we'll sort again, and we can see all the products by subcategory that are really just killing us and are maybe not worthwhile to make anymore. So we're gonna have to reconsider making the 3.6 cubic foot counter height office refrigerator. At least for Texas, it's not very helpful there. And then when you back out of that subcategory section, you can also click somewhere neutral in the dashboard or click on each thing that you had selected to unselect it and go back to the main part of your visualization and start it all over again. Now let's move on and take a look on how to create parameters and sets. So new sheet, and let's make a quick visualization that will apply our parameters and our sets to. So let's take a look at all of our customers by their sales, and let's sort customer name descending by sales. Great. So now we're going to make a parameter that will allow the user of the dashboard to choose how many customers they want to see, how many of our top customers that they want to see. So let's click this down arrow and click Create Parameter, and we will name it Top N Customers. Great. We're going to make it an integer, and we're going to give them the option to choose the number of customers within a range. Our low is going to be 5, so we'll let them see 5, or up to 20, and we're going to let them skip with step size of 5. Let's start their current value right in the middle with 10. Okay, so now if you want to see how this parameter looks, you can come down to parameters. Before we only had dimensions and measures on the left side of our Tableau workspace, but now we have parameters that has appeared once we create a parameter. We can right click on that parameter and click show parameter control, and we can see our top end customers. Right now our parameter control isn't built into any of our visualizations, but you can see how it works. We allow them to go down to 5 and up to 20 with steps of 5. Great. Now we're going to create a set. A set is a custom field that defines a subset of data based on some conditions. So the set we're going to build is going to be based on customer name. So when you right click on customer name, you can come down and click create, hover on create, and create a set. So far when we created a parameter and a calculated field, you clicked here with this down arrow and you saw create calculated field and create parameter, but it's not there. A set has to be based on an existing field, so you come and you click on the field you want it to be based on and then hover on create and you see set. So here's how we can create a set. Let's name it top N customers by sales. So we're going to allow them to select the top N customers and have that select our top customers by sales. So we want this set to include anything that is in the top, however many they define by the parameter, by sales. So you can come over here to top and change it to by field. We want it to be top, but not just top static 10. We're going to click here and our parameter shows up. So it's going to be top N customers. And then you can choose another field here for it to be defined by, and it's sales. And we want it to be by sum of sales. If we wanted it to be by the average profit, we can come here and click profit and change this to average, and now we would see our top N customers by average profit. But we want sales and sum. Okay, so we've created our set, and we can drag it onto rows to see how it works. And we can see these are our top 10 customers by their sales. And we have this in/out that's generated by our set. So if we take our set, first let's see how this line moves when we change our number here. So right now it's 10. When we move it up, we see our line moves down to include the top 15. And now we can quickly see our top 20. We'll go back to 10, and let's grab the set and drag it onto our filters. So now we have filtered the data down to our top 10. If this were applied to a dashboard, this would allow the end user to see the top 10 quickly and then maybe expand it out to the top 20 if they're interested in that information. Now let's move on to creating a donut chart. So a donut chart is basically a pie chart with a white center. So let's start by building a pie chart, which in Tableau is pretty easy, especially if you use Show Me. So let's create a pie chart for each category by sales. So we're going to click category and then we're going to control click sales. So we have them both selected. We'll come over to Show Me and click pie. And there we have our pie chart. We'll close Show Me. Let's come up here and click entire view so we see our pie very clearly here. If we wanted to have one pie for each region, we can take region and drag that onto columns. So we have one column for each region and then one pie for each of them. You can see that the pie varies in size based on sales as well as the angle is for sales. So East has more sales in general than South, and this helps you to see that technology has smaller sales in the South than it does in the East. So I recommend keeping, if you're going to make pie charts, allowing the size of the pie chart to be affected as well as the angle by whatever measure you're using. But for our purposes for donut charts, we're going to want them to all be the same size. So we took sales off of size, and now we have all of our pie charts the same size. Now we're going to make what's called a dual axis chart, and to make a dual axis chart we have to have two axes. So let's grab number of records, and we'll grab it and drag it to rows, and we will change it from sum to minimum. And that's because every record will have a minimum number of rows of 1, and then they all end up on the same axis. Great. And now we're going to make a second number of records by minimum. And we can do that by doing those steps again, by dragging number of records up here and changing it to minimum again. Or a quick trick that I can show you is if you want to duplicate anything you have on the chart here, you can just hit Control and then click and drag it, and it will duplicate it. So if you wanted your number of records to also be down here onto your details or on your labels, you can Control click it and then leave it there. Great. So now we have our two axes, and we have our two marks cards that each affect their own set of visualizations. So let's go to this top one affects these. So let's show that by changing the size. And it's made these bigger. And this bottom one affects these. And we'll do that by changing it to circle. So now each of these are a circle. Let's take category off of color, and we can take sum of sales off of detail. And let's change the color to white. And now we're going to put this white circle on top of our pie chart by clicking here on our second measure and clicking dual axis. And now it's got them lined up one on top of the other. And we have our donut chart. So if we want our donut slices to be a little thinner, we can change the size of our inner circle and make it bigger. Perfect. And so now we have one pie chart for each region, one donut chart for each region. And if we wanted to take this header and put it inside of our pie chart, what we can do is take region and put it on the label for the circle, and it's putting it down here. You can come and edit that by clicking on label and changing its alignment. So let's put it in the middle. Perfect. So now we can see our header here, so we don't need it down here anymore. You can right click and click show header, and it hides that header. We also don't want to see our labels for our axes. So we right click and click show header there, and now we just see our pies. So to get how the number of sales here for each of them, let's go to, remember, our pie marks card, and let's take our sales and add it to label. So now each of our slices of pie can tell you how much sales they have. If you take the sales here that's on label, right click and click format, we can change that to currency. And let's get rid of our decimal places. Perfect. Now close formatting, and let's say we want the total amount of sales to be in the middle here with central. So we go back to affecting our circle, grab sales, drag it to label. So now we have 4 donut charts formatted to allow us to quickly see the sales numbers for each segment and also for the donut as a whole. You can also change the colors that Tableau selects for each slice by coming to the marks card that has color for the pie, so category color, and clicking edit colors. And you could change it to any of these automatic ones, where if you double click on one, it gives you all of the options for colors that you could possibly want. There's also several different palettes you could choose from. So let's say we like this one, and you can just click assign palette and it will grab those off of there. Those look very similar to what we have already, so I'm going to pick a different one. And click assign palette, click apply. And this allows you to make some color changes to fit your business a little bit more specifically. Perfect. Let's say we make our pies bigger. Increase that size, and we'll also increase the center size. Oh, not that much. Perfect. Now we'll use a similar technique to create the two-dimensional pie chart. A two-dimensional pie chart can be used so that you can show 2 pie charts at the same time, or a pie chart that's kind of split up by different categories. This has been available in some other tools, and Tableau can do it too. So let's just demonstrate that. We're going to start again by creating our generic category by sales. So we'll control click sales, we come over to show me and click pie, and it makes our pie for us. It remembers the colors that you have determined in other pages, so that's a nice feature. Again, let's make it entire view so we can see our pie nice and big. And now we're going to create our dual axis again. So we grab number of records, put it on rows, and see how it adds an axis, but each one of these categories has a different value for the number of records. However, they have the same minimum value for number of records, and it puts them all back onto the same spot. Great. And then we will control click and drag to make our two axes. And let's come to our top one and make it bigger. That affected both of them because we still have sales on size for both of them. So sales is affecting the size of the pie chart as well as the size of the angles. So let's take sales off of size for both of them and make the second pie chart a little smaller. Perfect. Now let's also affect our second pie chart by having the color defined by region instead of defined by sales. Let's talk about how I'm replacing it with region. So you could change the color by dragging region onto color, and that replaces it. Or let's go back and we can drag region right on top of the thing we're trying to replace, and it will replace it there. Great. So now we have the smaller circle that's going to go on top, split up by region with the angle defined by sales, and the category is on the top one with the angle defined by sales. Let's pick some nicer colors. Maybe we'll use the same palette we used for category. This one seems right, but we'll pick different ones than those three. So we click on the one we want to change and click on the color we want to change it to. I'm just going to keep following this right down. Apply. Great. And then we put it on top of the other one by clicking dual axes. Now, sometimes it's easier to see these when they have a border. So we can come to color, we click border and add maybe some black lines. This will allow you to see the inner pie separate from the outer pie. Maybe our border could have white lines. How does that look? And we can make them both bigger, like we did before. Whoa, not that big. And you can also add labels like we did before. We'll take sales onto our labels here. And you can see that hovering allows you to see all of the information you need. Now, one more thing. So while we like to hide this axis, we'd also like to maybe hide this grid line that's occurring. So you can click right click and format. And let's go to our lines. Change that 0 line to none. Perfect. Get rid of some of the clutter on this visualization. I still feel like this outer pie should be a little bigger. And we want to clean up our tooltip so it doesn't have min number of records in it. This piece should be 100% behind the scenes. So we can come to tooltip. Right as you click on it, it'll pop up with everything that's in your tooltip. And we're just going to erase min number of records. I erased too much. You need to leave your angle brackets. Okay. And now this piece of the pie no longer has that. The inner one, let's do that there too. Min number of records, remove that right out. And there you have it, a two-dimensional pie chart. And here are our donut charts. This demonstration goes to show you that even when Tableau doesn't have visualization you're looking for in their basic show me options, you can still get to it. So donut charts aren't included up here, and neither is a two-dimensional pie chart, but without too much extra work we can make it happen. These visualizations are a little bit more complex than your everyday visualizations, and so I recommend going through this tutorial with the dataset and following along. If you want access to the dataset, just comment below and the Simplilearn team will get back to you. Also, comment below with any questions you have. At this point in the presentation, we're going to put together some dashboards. So first, let's build our worksheets for this dashboard. We're going to build a worksheet called Sales by Year, which adds the name up here. And we're going to take our order date and drag it onto columns. And now we want this to be a continuous axis. So we're going to change it to our continuous year. And now we have an axis. And we're going to look at sales. So now we have our sales by year. If we want labels on each of these dots, we can drag sales onto labels. And if we want to have different color lines for each region, for example, we can drag region onto color. And that splits our lines up into the different regions and gives us a legend over here. Perfect. Now we're going to duplicate this sheet by right-clicking down here and clicking duplicate. Now we have sales by year 2. Let's rename it to profit by year. And then let's drag profit right over top of sum of sales so that it replaces it with profit. Now, it's been replaced with profit, and all of these different data points are here. However, it's still showing the title of sum of sales, and that can be very confusing. So always make sure that your labels are consistent with your data. So let's take profit and drag it over top of the labels as well. That's more consistent with our axis. So now we have sales by year, and we have profit by year. Let's do a couple of things to clean these up, like right-click here, go Format, and we'll change our numbers to currency custom. And now it's marked as dollars. One thing you can do in Tableau is, let's undo that. Since sales is going to be dollars pretty much everywhere we use it, we can define our default property for these numbers. So when we right-click on the measure here, you can go to default properties and you have the options to change the defaults for any of these things. And we're going to change our number format. Change it to currency custom, no decimal places, hit OK. And that also has updated this sheet. Now that only works on places where you haven't specifically defined it to be formatted differently. So we could still define it to be different here on this sheet than it is on any other sheet. Let's do the same thing for profit. Change our default properties to the same thing. Great, now let's build our dashboard. We're going to call this our overall dashboard. Change our size. This size is a personal preference of mine. I think it fits nicely on the laptops that I use and that is used by most of our customers. Now let's drag sales by year. Now watch what happens when I drag it on here. It brings sales by year, but it also brings the legend for the region that was created. The same thing should happen with profit by year. It's detected that the same legend is being used, so it didn't bring over a second legend. And we have highlighting turned on. Let's see if this works for both charts. We click on central, and you see it highlights central in both charts. That's great. So now we have a dashboard showing us profit by year and sales by year. But let's say we want to be able to filter this dashboard to just maybe one category. So let's go back to our sales by year sheet and let's drag category onto filters. And now it's going to let us select, we're going to select all and hit OK, and then right click on category and click show filter. So now it is over here, and we're going to do a similar thing on profit by year, but we'll do the shortcut where you come over here to category, you right click on it and you just click show filter, and it puts it here and it puts it here. So now we have a filter here for category and a filter here for category. And so when we go to overall, we can come to our drop down here, more options, hover over filters, and you can see category. Now here's an interesting thing that we'll see. Even though we have a category filter on both charts, when I take furniture out, you can see only sales by year changed. And profit by year stayed the same. Now why would that be? That's because we have two different filters for category, one on the sales worksheet and one on the profit by year worksheet. I'll show that by clicking here, going to filters, and grab category. Now we have category that will affect profit by year and not sales by year. That's not what we want. We want one filter to affect them both. So let's back it up a bit. take these back off. Let's go to profit by year, and we're going to take off category. Let's go to sales by year, and we're going to say we want this same filter to affect both worksheets. So we're going to right click here, hover over apply to worksheets, and click selected worksheets. Now we select sales by year is selected, and we select profit by year. Okay, so when we go to the profit by year sheet, you can see that it now has category on there. Let's go to overall. Let's come here, filters, category, and now we have a filter that affects both worksheets. There we go. Let's format this filter a little bit. We'll come to more options, and we're going to select, we want them to be able to select multiple values still, but let's do it in a drop down. So now you still have those options, but it is a little bit more compact. Let's do a couple more filters. So we can do by category, let them filter out regions. Let's do it the shorter way. Right click, show filter, there it is. Apply to worksheets, selected worksheets, both of these. Okay, dashboard, filters, and by region, multiple values drop down, and let's let them change their time selection. So this one's a little bit different. Since we've already determined that we wanted year and we wanted it to be continuous, filters for continuous fields are a little bit different than filters for these discrete fields. And that's because continuous fields are a range instead of just a list. So we don't list out a continuous field, we make a range for it. So we've already defined that we want it to be continuous year. And if I come over here and click on right click order date and click show filter, it's doing discrete year by default. So remove filter. If you drag order date onto filters, it lets you pick what you want it to look at. Let's come up here to year, that's already marked as continuous, and click show filter. And now it is year, but it's based on a range, and we have this slider. And you can see how that slider affects our visualization. Let me show you a trick to make this apply to both. Not a trick, but just if you have not applied it to both worksheets, but you already added it to the visualization. See, it's here, but it's only affecting one worksheet. You can change the worksheet's settings right on the filter instead of having to go to the worksheet where the filter exists. And it will only give you the options of the worksheets that are on the dashboard. So there we have it. Now it affects both. And now we have our overall dashboard. Now let's say you want to be able to see the total sales on this chart as well as the sales split up by each of the regions. We can do that as well. So let's go back to our sales sheet. As a quick tip, you can go to the sheet by clicking this Go to Sheet button here or here in the event that you want to go to a sheet but you don't want to scroll back and forth to find where it is. So go to Sheet. Now we're going to do a dual axis chart again like we showed earlier, and I'm going to Control, click and drag. So now we have sum of sales twice. This marks card affects the top one. So we can see that by, if I change the opacity, how it changes the color right here. This is the top one. And this marks card is the bottom one. And we're going to remove region off of color. And that makes our combined one line again. Perfect. Now if we want this to be on the same space as this, we right click here, the second measure in the rows section, and click dual axis. So let's put it right on top. I can see this versus this. Now, if we wanted to, on hover, show that this is overall sales, we can click on tooltip. Region is missing because we don't have it with the color by region anymore. So we'll erase that and put, oh, we don't want it to be orange. Let's make it black. Overall sales. Okay, so when you hover here, it says overall sales. So we can see the difference easily. Let's make it a little bit more of a color that'll stand out. Just a little darker than the others, perhaps. So when we go back to our work or our dashboard, we can see sales and we can see our overall sales. Let's do the same thing for profit by year. Go to sheet and control, drag, release. We'll go to our marks card for this second sheet and pull off region, make it darker, change our tooltip, not orange, overall profit, okay, and right click, dual axis. There we go. Now I forgot to do one thing on the last dashboard. When you make a dual axis dashboard, it doesn't necessarily sync up these axes. And so this axis over here is for the overall line, and this axis over here is for the region line. So if we want it to stay that way, we should edit our axes, and instead of calling it just profit over here, we will change it to overall profit, and over here, profit by region, just so that it's clear which axis goes to which one. Or you can come here and click synchronize axis. So it's very clear that this is much bigger than these. And if you synchronize the axis, let's go back before we named him. Okay, synchronize the axis, then we don't need both of these headers. So we can come here and click show header and we just have the one. Let's do the same thing on sales by year. Synchronize. Always good to make sure that your axes are either synchronized or well labeled. And let's hide it. Let's see what it looks like now. Great. Okay, one thing to keep in mind. When we do filter to just one region, the lines are going to end up at the same spot. If we filter to 2, then it's only the sum of those 2. So perhaps the header overall sales and overall profit isn't quite accurate because it isn't overall necessarily when we have it filtered. Why does this happen? Why doesn't this line always show the total no matter what you select here? Well, that's because this filter applies to the whole dashboard. So it filters this line to those regions just as much as it filters these lines. So I'm going to remove out that tooltip line because it could be a little misleading. Let's continue on and make a dashboard that digs a little bit more into sales specifically. Great, so we'll make our first sheet. We'll call it sales by region. And we're going to make another pie chart. So let's do it using show me. We'll click on region, and then we will control click on sales, open up show me, click pie. Let's close it again. Great, so now we have the sales by region pie. We'll make it the entire view, and when you hover you can see that it's showing us sales in dollar amounts. Now it would be more like a pie for it to be percentages. So a lot of pies, each of these slices is shown as a percentage of the whole at 100%. So let's come here to our slice size. We'll right click on it and we're going to use what's called a quick table calculation and change it to % of total. So now when you hover, you can see that the West is 31% of the pie. Great. Let's also label each of these slices. So I'm going to control, click, and drag region onto label and add region to the labels. I'm going to undo that and show you what would happen if I just dragged region onto labels without copying it, without holding control. It will move it and get rid of our colors, and we don't want that. So we're going to control and drag. Another way to do this, let's go back, is by taking region and dragging it onto label just straight from over here. But in this case, for the sum of sales where we've applied the quick table calculation, we want that quick table calculation to also show up in our label. So I'm going to control and drag, and it brings that quick table calculation along with it. If I were to undo, just drag sales on, it's going to go back to that dollar amount, and I'm going to have to add another quick table calculation. So instead, control and drag. That's probably one of my very favorite Tableau tricks. Great. Now let's add a filter for region. So I'm going to right click here and click show filter. And we will make sure that this gets added to all of our sheets once we've made them all. Okay, next sheet. We're going to call this sheet sales by state. Let's do a map. Great. So one way to get your map started is to double click on any of these dimensions that have a globe next to them. So since we want to go with state, we can double click on state and it starts mapping out state. So what it does is it adds latitude and longitude to our rows and columns that are generated here. And another way to get going, so let's go back, is to click on the geographic part you want and then control click on sales like we did for for our pie chart. Come over to show me and choose one of our maps. We could do it with the circles, but we're going to do a filled map. Click on that. So now we have our filled map based on state. We can choose one of these different palettes if we'd like. Let's try this one. Or blue teal. Or we could do green, so that darker green means more money. Great. So now we have all of our states colored by sales. Let's also control and drag sales onto label. And you can see we have the dollar sign and the money formatting that we made earlier. And let's control and drag state onto label. Now maybe we want the state to be on top, so we can click on label and it pops up with all these different options. And if we want to edit the text, you can click here on the ellipses and edit it there. So let's cut state and paste it at the top there. I think I lost my center alignment, so we'll do that again. Hit apply, see what we think. Great. Okay, so now you can see that it puts the state on top. You can also see in some of these places where they're super close together that you can't see all of the states labels, and that's because this option here in labels is unchecked. Allow labels to overlap other marks. So Tableau senses when the marks are too close together and it's going to become too hard to read, and will hide anything that overlaps with each other. If we click this option, now you see everything, but it gets a little crowded over here. So let's unselect that and you'll be able to see what the sales are upon hover. Great. Now we have our sales by state. For filters for this one, let's right click on sales here and click show filter. So basically wherever you're using your metrics, your dimensions or your measures, you can right click on them and create your filters. So now we could the lowest amount for a state is $920 for sales for this time period, and we could filter out ones that have sales lower than that. But I think this isn't what I want. Let's remove that filter. Let's do it for the state. Show filter. Great. So now we could filter out a state. We could just show Arizona or show them all. Excellent. Let's move on to our next visualization. New sheet. Rename it to be called sales by subcategory. Great. So we're going to drag on category onto columns and subcategory. Because of our hierarchy, press plus. Now we have subcategory and category. And let's bring on sales. It's defaulting to this bar chart, which is perfect. That's what I want. And now we could color it by subcategory. And this is a discrete coloring. We could also color it by sales. And this is a continuous coloring. So the darkest corresponds with the height. Now we don't need to do this. There is already an indicator of who has the most sales, and that's based on the bar height. So if we wanted to color it by subcategory, then each one of them gets their own color. We could color it by category to add to the distinction between the different categories. So that's very clear where they start and stop. Let's do by subcategory. Excellent. So now we have 3 different dashboards. Oh, let's add some filters for subcategory. So let's bring on category as our filter. So we'll right click here, click show filter, and there's category. And let's do a filter for our date. So we're going to come here to order date. Let's drag it onto filters and let's click years. Now these are all the years options. We'll click all and hit OK. Right click here and click show filter. So now instead of doing a range where we could drag that line, now we have discrete filter, and so we can check and uncheck boxes to choose what years we want to see. Awesome, let's start with our dashboard. Let's call this dashboard our sales dashboard and change our size. If you have any questions about different sizes, what's available here, be sure to ask that in the comments below. And let's start with pulling on our sales by region. So last time we pulled on a chart, we saw that it added the legend for us. But this time you can see it added both the legends and the filter. So last time we created the filters after we built the dashboard, but this time you can see that the filter gets brought in when we brought in the dashboard. Let's do our sales by state, side by side here, and let's do sales by subcategory underneath. So I dragged it. You can see how I pull it towards the bottom of the dashboard, and it kind of fills in the space where it's going to be and then brings it in. So now it's brought in all our filters and all of our legends. It defaults to putting the filters and legends over here. We're going to click select layout container. It's going to select what they're all inside of. And we're going to make it take up this whole side, but it doesn't need that much space. So you can see in Tableau there's a lot of dragging, there's a lot of dropping, and a lot of resizing to get things the way you want them to be. Give our map more room. And we have a mixture over here of legends and filters. Let's move our legends out of there. So we can grab this legend and come and put it on this side. And this legend, come and put it over here. So that we're getting a little bit more near the visualizations they belong to. This legend goes up here with this one. I'm going to actually click here and change it from a tiled, so right here it says tiled object, to a floating object. That lets it sit on top of a visualization. I'm going to put it on top of this visualization right up here. Excellent. And then we have this one that's showing us the size of sales. That's because on this dashboard it says that size is determined by sales, but since it's just one circle, there's no size comparison. So it's not like we have several circles and we have to look and see which one's the biggest so that we can tell the amount of sales. So we don't need this legend and we can just remove it from the dashboard. Let's clean up some of these. We have several different versions of what your filters could look like. So my personal favorite is multiple values drop down. It gives you some of the most flexibility. But if you wanted them to only be able to select a single value, you could turn it into a radio button list so that it's a selected all or it's one at a time. You could also do a drop down or a slider and make that happen. A slider is a little bit different from a range. On a range, you can see that we could edit either side, and it's picking everything in between. But with discrete values, if you say everything in between, it doesn't make a lot of sense because what's everything between furniture and technology? We don't know that office supplies goes between those. There's no order. So let's do multiple value drop downs. For big ones like state, there is the option of searching. So I know I want Utah, and I search and there's Utah, instead of having to scroll through the list. This could be really helpful for if you had a filter by products, and that will allow somebody to look at just one product at a time if they know their name of the product, but also not have to just open up the product list and scroll and scroll and scroll, since there are a lot of products. So we can filter by region by doing this. Oh, this is a great reminder. You saw that this did not change all the visualizations. We have yet to apply these filters to all the worksheets. So let's do that right now. Apply to worksheets, selected worksheets, and we will click all on dashboard. Hit OK. we'll do this again. Until we have selected them all. Great. So it's really nice you get to choose what worksheets you wanted to apply to, because in the event that you had maybe a total number up here at the top that you just wanted to stay the same all the time, no matter what they selected, you could make that happen by not selecting that worksheet to be changed by these filters. Okay, great. So we can change what region we're looking at by selecting central here. And then we're just looking at central throughout all the visualizations. I love looking at it on a map and seeing just one at a time. It just really makes the region name just stand out to you. But if we wanted to use this as our filter to filter the rest of the dashboards, we can click this Use as Filter button. And now when we click on central here, it stays in context here, but the other two dashboards change. One thing you may notice is that Texas is not the darkest on this chart because of the scale. The scale goes up to 500,000 there. But then when we click on central, the scale updates just for what's selected. So everything else is filtered out, and now the darkest of the dark is only $170,000. And Texas becomes the darkest on the visualization. There are some ways you can change that, but if you're wondering why do my colors look a little differently when I filter, that's why. Great. We could also click Use as Filter here. So if we just wanted to look at Texas, we click this. This updates to just Central. This updates to just Texas down here. And unselect by clicking on maybe another state, or when you click on the state again, it should unselect. And we could do the same thing here, or if we just want to look at one subcategory and say, oh, let me scroll down a bit, storage. Now everything updates to just storage. It's interesting. I wouldn't have known very quickly that there are some states that didn't have any storage sales, but now when we click on storage we can tell. I showed you before that you can control click and look at binders and storage, and it puts those two together. Also, in Tableau, you can drag, and we could select all of these. So we have art, binders, envelopes, fasteners, labels, paper, and storage. And none of those are getting sold here. I don't know what's up with Wyoming. Excellent. So now we have our sales dashboard. And let's get started on our next one. Our next dashboard is going to be the profit version of this dashboard. So some of these visualizations we can use again. So let's go to sales by region. Right click and click duplicate. Rename it to profit by region. Now you have to be careful whenever you go to reuse a visualization, because like I mentioned before, you got to make sure everywhere that sales is used, you have to replace it with profit. I'm also going to drag this sheet to be more at the end here after the sales dashboard, just to keep them separate so that we have the sheets that lead up to overall, then the sheets that lead up to sales, and then we'll have the sheets that lead up to profit. Great. So we'll grab profit and drag it onto angle size, and that updates the angle size. Drag it onto the size of a circle. Shouldn't make a difference since we only have one circle, and onto the text. Now when I dragged it on, it didn't do the percent of total anymore, so let's change that to the quick table calculation of percent of total for there and for the label. Percent of total. There we go. Now we have our percent of total again by region. Okay, here's another thing. Since we duplicated that filter, it's going to be using that exact same filter. You see, it's using region from sales by region, all the sales dashboards. But we don't want that. So let's remove out all the filters here and these action filters that are generated by our filtering. Those come from this. These are called action filters. And it's generated when we click this Use as Filter button. Okay, back to profit by region. Great, we're clear of filters. And let's add back in a region filter. And this one no longer has the icon that shows you that it affects multiple sheets, which is what we want for now. So you might want perhaps there would be a situation where you would have two dashboards and you would want these filters that you put on here to affect both dashboards. And in this case, that's not what I want. Great, so another one we can use the basics for is sales by subcategory. So let's duplicate that. Great. Profit by subcategory already exists. We made this earlier. Tableau will not allow you to make a worksheet that has the same name as another worksheet. You can call it number 1, or since it does put the title up here, you can put an extra space at the end, or it does detect that space. It counts it as a different title even though it's the same title just with a space. That does cause some issues. So like when we're looking here and we're saying, oh, profit by subcategory, I want that. Oh, this is when we made it. But you don't want this one, you want this one, and it gets a little confusing. The nice thing is when you're dragging things onto your dashboard, when you hover, you should get a little picture here of what dashboard, what visualization you're looking at. It really helps you to make your decisions and not just have to do it by name. If you're a little bit disorganized and you have all of these called sheet 5, sheet 7, you won't know exactly what that is right away, and so that little preview is very helpful. Great, profit by subcategory. We'll do the same thing by removing out all our filters. So I just click on it and hit delete. You can also control click and then hit delete, or you can drag them off into a space that's not the visualization space. Great, and we only have sum of sales right there, so we'll change that to profit. And we have some negative profits there. We'll keep the colors the same for consistency between the two dashboards. And let's bring on category as a filter. Okay, show filter, there we are. And let's do our order date filter right now. Order date, we'll do years, okay, all the years. So it gives you this option here because it assumes that you're making a filter because you want this dashboard to just be filtered to your selection. You can do that. You can make a filter that isn't exposed to the end user. So let's say you were making a big dashboard and it was just focused on furniture, and you don't want them to be able to select a different category because of your analysis. You can make that happen. You can just click furniture and not show this by clicking hide card here. But in this case, we want to be able to make this interactive in a lot of different ways. Great, profit by subcategory exists. Now, instead of our map, we're going to make an area chart. So I'll rename this and call it profit over time by category. So we're going to bring on our order date into columns, and it goes to our discrete value. Let's change it to our continuous value so we get the axis. Let's grab our profit onto rows, and it makes us a line chart. We're going to change that to an area chart. An area chart is nice because when you split it up by category, by dragging category onto color, you can now see what category is responsible for how much profit, like you do with a line chart. However, its area is what defines that, so you can see that area over time and do comparisons. And also, it stacks them on top of each other so that you can tell that for 2013 our profit was around $50,000 really quickly. Otherwise, we have to add that line, this line here, and it makes these lines smaller and lower, more difficult to see. So back to our profit over time by category. So that's some of the benefits of having an area chart. And if we wanted to go a little more detailed than year, you can hit this plus. And now we have over quarter. We have some negative profits. That's interesting. But let's go back to over the year. Great. And for this one, we're going to make one more pie chart. So we could start from scratch, or we could duplicate our profit by region pie chart, which I'm going to do. We're going to do this for the comparison between a pie chart and an area chart. So it's going to be profit by category, but not over time. So right now it's profit by region. Let's drag category right on top of colors there. And now it's split up. It's having some trouble because it's splitting it by category, but because we brought region onto text, it's also splitting it by region. So we have region, 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 region inside of this category, and we don't want that. So we're going to drag category right on top of region here as well. And now it's just the 3 segments. So whatever you have in this marks card, unless it's on tooltips, will affect your level of detail in the visualization here. When it's on tooltips, sometimes it won't change the level of detail, but it could have an effect on, like, so if we brought, oh, let's do this right now. So right now the level of detail of this chart does not go to the category by region like it did before. You can bring it onto detail here, and it won't affect color and it won't affect labels, but it will change the detail, and you see how it splits it out again. This is what it would look like if it's by region, by category, and you have much more slices to this pie. We'll go back. But if we take region and put it onto tooltip, it's not at a low enough level for that tooltip to make any sense, so it's going to put that star. You see region is star. That's because this section of the pie covers multiple regions. If we filtered the region to just central, now it populates. So there are sometimes benefits to having it in there, even when at all levels it doesn't make any sense, but we won't leave it there. Excellent. So you can see how the color is what determines, is a big part of what determines how many slices you get. The level of detail for the whole chart is a big factor as well on how many slices you get. Great. Profit by region, profit by category, by subcategory, and by profit over time. And we have our category filter. We don't have our subcategory filter yet. We grabbed category, but let's right click on subcategory and click show filter. There we go. Now we have a filter for category and subcategory. Here's our region one. We have region in 2 places and we don't want that. We want it to apply to all of them. We'll do that when we get to the dashboard. And we have category, year of order, date, and subcategory. Great, those are all the filters I wanted. So let's build our dashboard. We'll call this our profit dashboard once I get it set to the size I want. Profit. We'll start with profit by region. And we'll have our profit by category over time next to it. Great. We'll give that some different space. Have this at the bottom, have this underneath there. Now it's bunched all these up next to it, so let's again drag it over to the side. It's always good to pay attention to the highlighted section, and it gives you kind of an idea. Oh, you see, I accidentally dragged an individual filter instead of this whole section. So when I grabbed this, I didn't grab all of these. So if you want to grab all of these and they happen to be inside the same section, you can come and click select a layout container. And now I'm grabbing all of them. There we go. We'll do the same thing as before. You know what? I'm going to make these floating, because then it kind of sits inside of that same area. We'll make that one floating. And this one too. This category legend applies to both this chart and this chart. So that's very nice. And this subcategory legend, I won't make floating, I'll just put here by subcategory. And this profit by category doesn't need quite that much space. Let's give our bar chart some room. Excellent. We don't need the size of the circles. Make these drop downs. Now, because I didn't have to on this chart and this chart change profit to dollars, because we set that as the default, it definitely saved us some time. So I recommend setting default number formatting at the beginning of your visualizations. Really nice. Excellent. Now you can rearrange the order of these. So I like to have the date at the top. It's sometimes hard to get it to the top, so I take it the second to the top and I drag the top one down. And then category above subcategory, just for logical sense. Excellent. And we have our profit dashboard. Let's see. There is this checkbox down here called Show Dashboard Title. So if we wanted to have the title at the top here, you can click that button. any floating objects don't shift down like everything else did. There we go. So we could have that title, we could not have that title. That's up to you. Excellent. So at this point, we have our overall dashboard that looks at sales and profit. We have our sales dashboard, and we have our profit dashboard. Our profit dashboard isn't 100% complete because I forgot to make sure all of these filters apply to all of these worksheets. So let's go ahead and do that right now. Apply to worksheets, selected worksheets, all on dashboard. One thing that is nice from this view, it's really nice to click all on dashboard and you only see the ones on the dashboard. But you can click here and say show all worksheets in workbook, and you can see the rest here. So if you wanted all on the dashboard and you wanted this one or something like that, then you have the option to see them all. Great. Perfect. So before you ever publish a dashboard, it's always good to double check that your filters work. When you filter to just 1 year, this area chart becomes a lot less useful. But if you're looking at 2 or more, you start to see the shape of it. Great. Now we're going to take a look at linking from our overall dashboard to our sales dashboard. Great, so we'll go to our overall dashboard and we'll be creating what's called an action. So you can make an action on a worksheet. You can see right here, actions, or on a dashboard, actions. So since we're linking between 2 dashboards, this is going to be a dashboard action. Sorry, just trying to unhighlight there. But if you're ever looking for an action you made and you can't find it, look in the other one. Great, this is our actions dialog box. Here we can see the highlight that has been generated. When it says generated next to it, that means that you didn't come in and define an action. It was made by clicking this highlight button here. That'll generate an action. Or when we look on our sales dashboard, we clicked on this uses filter button. So we should have several actions here that were all generated. We have a couple different kinds of actions when you go to make an action. There's a filter action that we see when we click use as filter, a highlight action that we can see from here in region, and a go to URL action that we haven't used. If you have any questions about go to URL, please post them in the comments below. It basically allows you to be able to select a URL here, and so if you had a dashboard that had to do with maybe stocks, you could put in a URL here and then put your stock ticker symbol there, so that you could have a URL that would then take you to a finance website that shows you your stock information. It can get pretty cool. Okay, but we want to link from this dashboard to one of our other dashboards, and you actually do that using a filter action. So we're going to name that action Go to Sales Dashboard. And we want it to happen when we click on our sales sheet. So you see right here it shows us the 2 sheets that are on this dashboard. When we click on the profits dashboard, we don't want this action to occur. This is our go to sales dashboard. Now you can have an action occur on hover or select. You've seen select happen. That's what our filter uses filter actions use. And on menu. So we're going to do it on menu. And the targeted sheets, it defaults to this dashboard saying when I click on this, I want the rest of this dashboard to update. But instead, it's going to take us to our sales dashboard. So when we click on this, I want these sheets to update. Now, we're going to define what filters it's going to apply. By default, it's going to apply all of the filters based on what we click. So if we click here, it will filter to just 2013. Let's say we click here. It'll filter to just 2013, and it will filter to the region we selected. So, let's see what happens when we do that. Okay, it's just going to default. Okay, now when I click on this, it's going to filter to 2013 and west. Go to sales dashboard. This is where it pops up when you have it on menu. It's taken us to our sales dashboard. It is filtered to 2013 and West. Just so you know, actions will not affect these filters here. You see that it thinks all of them are selected because it creates a separate filter. There is such thing as show only relevant values for these filters. So if we click this, it will filter this to only the ones that are relevant. So we can see that it's only 2013 that this dashboard is filtered down to. But if we click all values in the database, this filter doesn't have only one particularly selected. It does have them all selected right now. So we can get here for that information, and to get back, we just need to navigate back to overall. Great, so it works there, but when we click on this up here, go to sales dashboard, we get a blank dashboard. Now, that happens because it's trying to pass region information to that dashboard, but this doesn't have any region detail on this line. It doesn't know what that is, so it's giving it a bad region value. So let's fix this. Go to our actions, we're going to edit our go to sales dashboard, and we're going to select what fields it'll filter on. We will filter on our order date, year, and let me go back to that. We clicked order date, year, and it goes to the target data source. Sometimes your target data source will be a different data source than the one that you are using for your source data source. Now, that gets a little bit complicated. Right now, we're just using one data source, so that's not something you need to worry about in a simple visualization like this. Okay, and we're going to add one more. We're going to add region, and it automatically selects region over here, but you could select it yourself. Let's see what happens here. Okay, if one dashboard has region in it and the other dashboard doesn't have region in it or doesn't allow you to filter by region, then sometimes you'll get an error here that will say it's missing out of your target dashboards. So we don't have any errors, so let's see what happens. So we go to click here, go to sales dashboard. What if we take out region, remove region, and we're just doing it based on year? Okay, click here, go to sales dashboard, and there everything is. So now it will filter to the year that you selected, so this is all 2013, but it will not filter to the region you selected. So even when we come here and we select West, it takes you to the dashboard, but it doesn't filter it to West. You have to do that yourself. So now we have links from sales to sales. Let's make one for profit to profit. Go to sales dashboard, add action, filter. We're going to call this go to profit dashboard. And we're only going to come from the profit table to make this happen. Let's go to profit and let's select our fields. We're going to do the same thing where it's only going to filter it to the year. Now you can see, oh, I started to type in. I didn't show you this before, but you can search text. So I started typing in year, and it shows you that under order date, you have all these different options. In this dashboard right now, if you remember, we're using the continuous one that is marked by the little calendar. So it knows it's a calendar date instead of just treating it like a discrete field. Okay. Excellent. Go to profit dashboard. And there we go. This visualization, like we said, when it's filtered to just 1 year, isn't quite as useful. But one thing you can do is for West here, we can select both years. I'm going to do it by control clicking. Click, click, go to profit dashboard. And now we've got 2015 and 2016. So that's how you do linking between the two dashboards. If you wanted to be able to include region as well, you could put a note in the tooltip for this, that this doesn't work for region, linking from this area doesn't work. Or perhaps you could not have this total line on the same visualization. You could have a separate visualization that shows the total or an area chart instead, and that will let you not have this problem of go to sales dashboard not linking appropriately. So now we're going to create our final dashboard, our segment dashboard, and it's going to use a parameter in it. So we'll get to take a look at parameters on dashboards. So let's rename this. We're going to call it profit and sales by segment. You don't have to name all of your dashboards a description of what they are, but it makes it really nice and easy. And it automatically puts it up here, but if you wanted to change this, you can just come in here and name this whatever you like. And then it will just show up here. So we could call this segment analysis. Click apply or OK, and there it goes. That means this and this does not have to be the same. If we go forward again, segment analysis and profit and sales by segment. That allows you to have some more useful names down here that make it easy when you're looking at them side by side, but have a name to match your dashboard up here. Great, so we're going to make a profit and sales. It's going to be a bars and circles chart. And we're going to bring in our segment that we haven't looked at yet. Consumer, corporate, and home office. And then we're going to look at it segment, and we're going to make a matrix with category. And we get to fill in this space with our visualizations. So we're going to do sales, and it's going to make these bar charts. So we can see for technology, by consumer, by corporate, by home office. And it is a matrix of bar charts. But we also want to be able to see profit. And right now it's making two sets of visualizations, but we want just one, so let's dual axis. And it's automatically changed it to circles. Also, it is not synchronizing the axis now because profit is blue and these profit is not anywhere near the same amount as sales, which makes sense. You shouldn't have profit that's higher than sales. So let's synchronize our axis. And let's change our sales. Our marks card over here is associated with sales. It's nice and easy when the two marks cards are based on a different measure to let you know which one you're affecting. And we'll change that to a bar. And now we have a circle on a bar chart. Now, if we had profit in front of sales, you can see how it's behind. And you can fix that by taking it to the back of sales. Another way you can fix it, say you wanted the profit axis here over here for some reason, you can right click on the axis and put mark type or move marks to front. Another way to change it. We don't need both of these, so let's not show that header. And we don't need this to be labeled profit because it's for both of them. So the way you get rid of that is actually you click edit axis and then you just erase the title. Oh, and you don't hit reset. You just erase the title and then you close it. So now no title here, but we still have the axis. And we have 3 sets of bar charts across. Excellent. The next chart we're going to build. Oh, so right now it automatically added the colors based on measure names. Measure names is a dimension that is created by Tableau, and it's just what it sounds like. We're coloring it based on the different measure names. One of them's named profit, one of them's named sales. And we know that you can come here, click color, and hit edit colors, and it will open this dialog box. But you can also come here and double click on a color, pops open that dialog box. Let's pick a palette. Let's see. There's a lot of different ones of these. Tableau 20. Let's pick colors from this palette. Profit can be... So you click here, make sure it's highlighted, click the color you want. Click here, make sure it's highlighted, click the color you want. Hit apply. And then you can come to color and make it a little more opaque. Whatever. When you make it more opaque, you start to be able to see through your circles. There are benefits, but also drawbacks to doing that. Anyway, so stick with the Tableau orange and blue. Great, we have our first chart. Our next chart is going to be called Top Customers by Sales. And this is where we're going to use our parameter where we made our top N customers. So let's bring in our sum of sales, make a bar chart for that. And then we're also we're bringing in our set. And so we have our in and our out. We're going to break up our set by our segment, as it's part of our segment analysis. And we'll bring in our customer names. And let's sort it. Excellent. Now you can see that when we sorted it, it didn't take this big guy and put it all the way at the top. It just sorted it each within its own section. Great, and so here we have our in and out, and that's not a super user-friendly title for our users of this dashboard. They're like in and out of top-end customers by sales. Maybe we want this to say something a little bit more user-friendly. So let's make a calculated field, and we're going to call it the top-end customers label. And we're going to go and say if, and we're going to use our set, top-end customers by sales. And since it's an in or out set, it treats this like if it's in top-end customers by sales. Then top, we're going to do a string. So it's going to be top, and then we want to use the number that's in our parameter. So we have to convert it from a number to a string, and we have to concatenate them together. In Tableau, you can use a plus sign. Top, and always make sure you have a space between what you're concatenating together. That's something that I tend to forget. Top space customers. So if they pick 20, it'll say top 20 customers. So if it's in the set, then top blank customers. Else, if it's not in the set, we will just call it other. And in Tableau, you always need to end your if statement with an end. Here it tells us our calculation is valid. While we're here, I want to show you a little trick. There's this arrow button here that can give you all of the different functions that are available within Tableau. And it even sorts it out by different categories. So if we didn't know how to make this into a string, we could go to type conversion. We could click on string, and it gives you an example. Also, when you click on a function in here, did you see how it's on date, and then I clicked on string, and I'm like, what does this do? Click on it, and it tells me. So this makes it really useful inside of Tableau. Also, in Tableau, you can make a comment in here. So if somebody's like, what's going on here? You can press dash dash or slash slash and type in, this is a more user-friendly title. Hit OK. And there we go. We have our more user-friendly title. We drag it here. We see our top 20 customers and other. And if we don't want to show this anymore, but we still want it in place, you can right click on it up here and click show header, and it hides it. So that in out is still happening there. And let's drag it to our filters, and there we have it. We have our top blank customers, and it tells you right there how many. And we need to come here to parameter, right click and click show parameter control, and that's how we can control these changes. So let's set it to 10 at first, and we have it our top customers by sales, but it's interesting to know profit as well. So we have really big sales, but how is their profit doing? So let's drag profit onto color, and you can see this person has a negative amount of profit despite their big sales. So that's important for us to know. And we can change our color like we did previously to go from red to blue, and we can change our center to 0, and now we can see the negatives really quickly. Now, they're not the only one either that have a negative profit, but some of our highest sales. That's great to know. Excellent. Those are our visualizations for the segment dashboard. So let's talk about filters really quick. We have this filter. We won't show the filter itself. We don't want to allow them to show in or out. We just are going to allow them to show how many. But we do want to be able to have them filtered by category. So let's show that filter. And by segment, show that filter. And then we'll have our parameter. Great. Let's make our dashboard automatic, as you probably read right there. The dashboard will resize to fit any screen it is displayed on. That can be really handy, especially if your visualization is really dynamic and can change. However, some visualizations, like this visualization for example, if it gets too squished, you stop being able to read things very well. So automatic has its definite pros and cons. So we're going to bring on our profit and sales by segment. And it already pops up with its legend and total customers by sale. And it pops up with its legends and filters, and it pops up with its parameter. Now we're going to close that and be like, if you don't see your parameter when you first bring it in, the parameter is affecting this sheet, and you can go to parameters and find it. But parameters are workbook wide, meaning that it's going to exist over here too. It doesn't affect this sheet. However, it's still going to show up there because it could affect, it is available for any sheet, and it's the same. There is no determining what worksheets this affects. This will affect any sheet that it is on. So if I've changed it to 10, and if I come down here and go back to the other visualization that uses it, this is why I should name my sheets. Let's see if I can find it. Nope. Here we are, sheet 13. In sheet 13, we have our top 10. So I've got a 10 and I've got a 10 over there, and if I change it to 20, and I go back to my segment dashboard, it is also changed to 20. So it will affect all sheets always. Very important to know. Great. So here's our visualization. Here are some of the more useful legends. So let's make this floating and put it over by the visualization it matters for. We can do the same thing here. Floating right up here. Floating does not work very well for if you were to make this an automatic dashboard so that the size changes all the time, because floating could end up right on top of your visualization and keep you from being able to see what you need to see. And let's make these affect all the dashboards in the workbook. Again, we don't have to do this for our parameter. It will already affect all the dashboards in the whole workbook. And format these. Another thing you should know is that there are more formatting options for these, including edit title. So it's already named it category automatically, but if you had, like here, oh, this is a great example. Edit title, top end customers, and you could change it to select number of top customers, or something like that. Give it a little more space. And yeah, these floating ones do not shift when you shift things, so it's always good to double check your floating legends. And this is a little bit more user-friendly than the title we made for the developers. And that's using parameters in a dashboard. Today in this video we learned about an overview of business intelligence on Tableau. We talked about how to install Tableau Public and how to connect to a data source. We also talked about creating calculated fields, like this one. We talked about making sets and parameters. We learned how to make a donut chart and a 2D donut chart. We learned about making dashboards and adding filters to those dashboards. And we also learned about connecting between dashboards.
Business intelligence is a set of processes and techniques to analyze raw data and extract information that helps drive business decisions. It helps you keep track of business data and draw valuable insights. There are several tools that play a key role in business intelligence. Some of the popular tools are Power BI, Tableau, and ClickView. Hi guys, welcome to this tutorial on what is Power BI. In this video, you will learn why Power BI is needed, what is Power BI, the various features of Power BI, and the different components of Power BI. Later, you will look at the architecture of Power BI, what Power BI service is, and how to create a Power BI dashboard. Finally, you will understand a case study on Meyer and do a demo using Power BI. Now let's understand why Power BI is needed. First, Power BI has the ability to access vast volumes of data from multiple sources. It allows you to view, analyze, and visualize huge quantities of data that cannot be opened in Excel. Some of the important data sources available in Power BI are Excel, CSV, XML, JSON, PDF, etc. Second, Power BI provides an easy-to-use drag and drop tool with features and functionalities that allow you to copy all formatting across similar visualizations. Power BI has exceptional integration with Excel. It helps you gather, analyze, publish, and share Excel business data. Power BI helps to accelerate big data preparation with Azure. Using Power BI with Azure allows you to analyze and share vast volumes of data. Azure Data Lake can reduce the time it takes to get insights and increase collaboration between business analysts, data engineers, and data scientists. Power BI allows you to get insights from data and turn insights into actions to take data-driven business decisions. Finally, Power BI allows you to perform real-time stream analytics. It fetches data from multiple sensors and social media sources to get access to real-time analytics. so you are always ready to make business decisions. Now let's see what Power BI is. Power BI is a business analytics service provided by Microsoft that lets you visualize your data and share insights. It converts data from different sources to build interactive dashboards and BI reports. As you can see, we have an Excel data about sales. Using this data, Power BI helps you build different charts and graphs to visualize the data. Now that we have understood what Power BI is, let us look at the important features of Power BI. First is Power BI Desktop. Power BI Desktop is a free software that you can download, and it allows you to build reports by accessing data easily. For using Power BI Desktop, you do not need advanced report designing or query skills to build a report. Second, as already discussed, Power BI supports stream analytics. From factory sensors to social media sources, Power BI assists in real-time analytics to make timely decisions. Third, support for multiple data sources is one of the major features of Power BI. You can access various sources of data such as Excel, CSV, SQL Server, web files, etc. to create interactive visualizations. And finally, custom visualization. Custom visualization is another vital feature of Power BI. While dealing with complex data, Power BI's default standard might not be enough in some cases. In that case, you can access the custom library of visualization that meets your needs. Let us jump into discussing the various components of Power BI. As you can see, there are 6 major components of Power BI. Now let's discuss them one by one. First is Power Query. Power Query is the data transformation and mashup engine. It enables you to discover, connect, combine and refine data sources to meet your analysis need. It can be downloaded as an add-in for Excel or can be used as part of Power BI Desktop. Second, we have Power Pivot. Power Pivot is a data modeling technology that lets you create data models. It also allows you to establish relationships and create calculations. It uses data analysis expression language or DAX to model simple and complex data. Third, we have Power View. Power View is a technology that is available in Excel, SharePoint, SQL Server and Power BI. It lets you create interactive charts, graphs, maps and other visuals that brings your data to life. Next, we have Power Map. Microsoft's Power Map for Excel and Power BI is a 3D data visualization tool that lets you map your data and plot more than 1 million rows of data visually on Bing Maps in 3D format from an Excel table or data model in Excel. Then we have Power BI Desktop. Power BI Desktop is a development tool for Power Query, Power Pivot and Power View. With Power BI Desktop, you have everything under the same solution and it is easier to develop BI and data analysis experience. Finally, we have Power Q&A. The Q&A feature in Power BI lets you explore your data in your own words. It is the fastest way to get an answer from your data using natural language. An example could be, what was the total sales last year? Once you have built your data model and deployed that into Power BI website, then you can ask questions and get answers easily. Now, let's see what Power BI Service is. Power BI Service is the software as a service part of Power BI. It is also referred as Power BI Online. To access Power BI Service, you need to log into app.powerbi.com. Now let me show you that. I'll go to Google, I'll open a new tab and search for app.powerbi.com. It's loading. But this is how the homepage of Power BI Service looks like. I've created some dashboards on it. First, you need to log into app.powerbi service. You can see I'm logged in. Now under my workspace, if I go to dashboard, here I've created a finance dashboard. You can see the different charts and graphs I have prepared and pinned it to the dashboard. So Power BI Service allows you to connect to your data, create reports and dashboards, and you can also ask questions to your data. Now as you can see in this dashboard, we have created some charts and graphs. So this is a tree map. There's a pie chart, there's a bar graph. Below you can see there are line charts and donut charts. It tells you the total sales that were made, the total number of units sold, the sales by product, sales by country, sales by segment, and lots more. One of the key features of Power BI is creating dashboards from multiple reports and datasets. Power BI Dashboard is a single-page visualization to tell a story. The visualizations on a dashboard are generated from multiple reports and each report is based on one dataset. A single-page dashboard is known as a canvas. The visualizations you see on the dashboard are called tiles. These tiles are pinned to the dashboard by report designers. Now let me go back to my dashboard. So this is called a canvas and each of these are called tiles. So on the top you can see we have 3 tiles. Now let's understand how to create and publish reports in Power BI dashboards. Power BI allows you to create different reports on Power BI desktop. These reports can be published on the Power BI dashboard using Power BI service. Here, you can see there is a Power BI report created on Power BI desktop. If you click on Publish, it will take you to the Power BI service where you can build a dashboard. Here is the button for Power BI Publish. Once you click on Power BI Publish, it will take you to the dashboard. So this is a single page Power BI dashboard on Power BI service. Now, let's understand the Power BI architecture. Power BI architecture is a service built on top of Azure. There are multiple data sources that Power BI can connect to. Power BI Desktop allows you to create reports and data visualizations on the dataset. Power BI Gateway is connected to on-premise data sources to get continuous data for reporting and analytics. Power BI services are basically the cloud services that are used to publish Power BI reports and data visualizations. Using Power BI mobile apps, you can stay connected to their data from anywhere. Power BI apps are available for Windows, iOS, and Android platforms. Now, let's look at a case study on how Meijer, which is one of United States' largest supermarket chains, used Power BI to solve its business problems. Initially, Meijer had become dependent on its IT organization to extract insights from its data. It was time-consuming and inefficient as you had to wait for IT to build every report. Meijer was unable to perform ad hoc and real-time analysis easily. So what Meijer did was, it connected Power BI to an on-premises SQL Server Analysis Services cube. This allowed them to refresh 20 billion rows of data in near real time. With Power BI, teams can now pull in the data faster and perform real-time analysis to derive insights from data. A bakery department inside Meijer used Power BI to compare its sales with regional performance. They analyzed where Meijer was behind the regional trends, focused on the problem, and created a solution. With Power BI, they can now drill down into hourly sales and send out a sales flash to 800 Meijer business leaders. So Power BI enabled them to standardize data sources and empower store directors and team leaders to develop and track that data to ensure what they can improve. Now, let's do some practical hands-on demo with Power BI. So this is how the Power BI desktop interface looks like. On the left, you have the report view, the data view, and the model view. The report view is where you visualize your data with different charts and graphs to build reports. The data view allows you to view the whole data, while the model view is where you check if there are any relationship between the tables. On the right, you can see the different visualizations that you can build. We'll quickly run through all of these in our demo. So here you can see there's a finance sample data that will help you draw insights about the sale of products in different countries. We will create a report to visualize different charts and graphs and analyze those sales. So let me go to my Power BI desktop. First, we'll import our data. So let me go to our Get Data tab and choose Excel as my data source. I click on Excel. So here is our finance sample data. We'll select sheet 1. You can see the data here. Click on it and then select Load. This might take some time to load the data. Now if I go to my Data tab, you can see the entire data set. It has fields such as segment, country in which the sales was made, the name of the product, the units sold, and the sales price, and many more. Let's start building our report now. I'll go to my report view. So first let me create a text box. Let me resize it. Let me name it as Finance Dashboard. We'll increase the size of the text. We'll use font Consolas, center it. We'll also add a background to this. We use blue color, change it to white, and increase the size. Now, let me first show you how you can create a matrix. I'll go to Visualizations and click on Matrix. Let me resize it. From the Datasheet tab, I'll select Sales and drag onto Values. So you can see the total number of sales that were made. Now, let me do some formatting. So I'll go to the Format tab, click on Column Headers. Let's add a background color and let me increase the text size to 20. Similarly, under Values, we'll increase the size of the text to 20 as well. We can also click on Border and choose the color of the border. Let it be black. So this is a simple matrix that we created which shows the total number of sales that were made. Similarly, let me choose matrix once again. Now we'll drag on the units sold onto values. We'll continue with the same drill. Under column headers, we'll add a background. This time, let's choose some other color, and under values, let's increase the size of the text to 20. Even for the column headers, let's increase the size of the text to 20. Again, we'll switch on border. Let me resize a bit. So here we have two matrices created for our report. The first matrix shows us the total sales that were made. The second matrix shows you the total units that were sold. Now let's move ahead and create a simple bar chart. So under visualization, I click on clustered column chart. Under this, we'll drag the date column onto axis and the sales onto value. Let me expand it. So it shows you the sales by year. This is the sales that were made in 2013 and this shows you the sales that were made in 2014. Now there's a drill down option which gives you more granularity. This depicts the sales by quarter. If I drill down further, you can see this shows you the sales by month. Also, you have some options like sort by and sort by sales. So you can see October month made the highest number of sales. Moving ahead, let me now create a pie chart where we will see the sales by different segments. Under visualization, I'll click on pie chart. Let me first resize it. Here, I'll drag the segment column onto the legend and the sales column onto the values. As you can see, we have the sales made by different segments. Government segment made the highest number of sales with 44.22%. Now let me add a border to both the visualization. I'll click on the pie chart and go to the Format tab. I'll switch on the border. Similarly, for the clustered column chart, I'll go to the Format tab and click on Border. Now let me resize a bit. Alright. Next, we'll create a very simple table that will depict the total sales made by each product. So under Visualizations, I click on Table. Let me bring this below. So from the data sheet, I'll first drag product onto values. You can see the different products and then sales just below it. So this depicts the total sales that were made by each product. And finally, it displays the total value of the sales that were made. This is same as the one shown here. Now let's do some formatting. Under Format tab, I'll go to Values and increase the text size to 15. Let me expand it. Also, under Column Headers, I'll increase the text size to 15. Then, let me go and add a border. Now let me create a map that will show you the sales that were made by each country. So first, let me create a new page and under Visualization, I'll click on Map. Now, I'll drag the country column onto Location. So you can see we have our map ready and we'll drag sales onto Size. You can see the different countries and the sales that they made. If I move the map, you can see the sales made in the Europe region. Let me resize it. I'll add a border to this. Now let me go ahead and create a donut chart that will show you the profit by each segment. Under Visualizations, I'll click on Donut Chart. I'll move this to the top. Now, from the data sheet, I'll add profit onto the values and segment onto the legend. If I expand this, you can see government segment made the highest amount of profit with 65.04%. Let me resize this and we'll add a border. Okay, in the final visualization, I'll show you how to create a tree map. This tree map will tell you the total amount of sales made by each product. So under visualizations, I'll click on the tree map. Let me expand it. I'll drag sales onto values and product onto group. So here you can see our tree map and the sales made by each product. You can see now we have our report ready. We have created two separate canvases to visualize our data. Now, if you want to change the color of these bars, you can simply go to the Format tab and under Data Colors, you can choose whichever color you want. In Power BI Desktop, you have an option to switch your theme. This will make your dashboard or the report look more attractive. So now we are under the default mode. Let's try out different themes. That's Frontier, it's Temperature, Solar, which is a little yellowish. The one which I like is Tidal. I hope this was helpful in making you understand the basics of Power BI and how it works. You learned the various features and the components of Power BI and looked at the architecture of Power BI. Finally, you saw a demo to create a report using finance dataset. In our previous video on what is Power BI, we had learned the basics of Power BI, its features and components, the architecture of Power BI, followed by a demo. In this video, we will learn what Power BI dashboard is, we'll understand how to create different reports in Power BI desktop, then you will publish a dashboard onto Power BI service, and finally, you'll derive insights from the dashboard. Now, let's understand what Power BI dashboard is. Power BI dashboard is a single page visualization to tell a story. Here on the screen you can see there's a dashboard which has been published on Power BI service. There are multiple charts and graphs that you can see. The visualizations on a dashboard are generated from reports, and each report is based on one dataset. A single page dashboard is known as a canvas. The visualizations you see on the dashboard are called tiles, and each of these tiles are pinned to the dashboard by report designers. Today, we'll be covering the following dashboard that you see on the screen. It will be a 3-page report where we will be analyzing the Superstore sample data. As you can see, there are 3 tabs. Now let me move over to our data set. So our Superstore sample data set is in the form of an Excel file. You can see there are multiple columns. You can see there's order date, shipment date, the mode of shipment, customer's first name and last name, the segment to which the customer belonged to, country of the customer, the city, state, and if you go towards the end, you can see there are the different product names, the sales, quantity sold, discount, and the profit. So the report that you see here and the one which we are going to create might vary a little in terms of the color formatting and the spacing, so you need not worry about that. Now let me go ahead and bring up a new workspace. So I'll go to File, click on New. This will take some time to bring up our new workspace. Now it will ask you for trying the free version, or if you want you can go ahead and sign in. I'll just close this. So here is our new workspace. Before creating the dashboard, we need to make some changes to our Superstore dataset. Using the features of Power BI desktop, first we'll extract the year, month and quarter values from the order date column. I'll go to Get Data tab, click on Excel as my source. I'll locate my file, it's on desktop, click on Open. This might take some time to load the dataset. I'll select the orders sheet. You can see the preview of our data here. I'll go ahead and click on Load. This will take some time to load the dataset onto Power BI desktop. I think we have successfully loaded our dataset. You can check that by going to the Data tab. So here is our dataset. First, let's make some changes in the format of the order date and the shipment date. I'll click on the order date. Under the Modeling tab, we have this data type and the format. I'll click on the drill down option. Under date and time, now let's choose the first one, which is in the format of DDMMYYYY. I'll click on it. As you can see, our order date column has been changed to that particular format. Similarly, I'll select the ship date column, go to the format option. Under date and time, I'll click on the first one. Here you can see even the ship date column has been changed to that particular format. Now let's extract the month values from the order date column. To do that, right click on the order date column, select new column. So this will create a new column if you go to the end. So there's a new column. Rename this column as month, and since we want the month value from the order date column, I'll search for order date. Since I want the month, I'll select month. Now if I hit enter, it will give me the month values from the order date column. Similarly, if you want to get the quarter values from the order date, right click, select new column, rename the column as quarter, then choose the order date column followed by the quarter name. Hit enter. So you can see you have a quarter column and it has all the values of the quarter to which the date belongs to. Now let me go ahead and create one more column. This time we'll create a new column for the order year. This time we'll extract the order year values. So let me rename it as year. We'll continue with the same procedure. I'll look for the order date and then select the year. Hit enter. So it gives you only the year values on which the order was placed. Now let's find which day of the week was the order placed. So we need to use the weekday function and give the order date as parameter, followed by which day you want the week to start with. I'll show you how to do that. So I'll click on order date, then select new column. Let's rename this column as day of week. I'll use the weekday function of Power BI. You can hit tab to finish. I'll look for my order date column, comma, I'll choose 2 here since I want my week to start with Monday and end on a Sunday. Hit enter. So you can see we have the day of the week column. So the idea to create this day of week column is to find out if the order was placed on a weekday or a weekend. Now let me go ahead and create one more new column. Let's name this column as weekday or a weekend. I'll use an if clause and pass in my parameters. For logical test, I'll use the day of the week column. So I'll search for orders and then look for day of week. If this day of the week is equal to 6, which means if it's a Saturday, or I'm using the or operator, if the day of week is a Sunday, that is 7, then it's a weekend, else it's a weekday. I'll close the bracket, hit enter. So you can see we have our weekday and weekend column. So moving ahead, another thing we can do is we can find the total number of days it took for the shipment of the product. This can be done using the DATEDIF function of Power BI. So let me show you how you can do that. I'll click on any column, right click, go to new column. Let's rename the column as days for shipment. Then I'll use the DATEDIF function. I'll give my starting date, which is the order date. So I'll search for order date, followed by the second date will be our shipment date, which is ship date, and the day. I'll hit enter. So you can see here it gives us the total number of days it took for the shipment of the product. Now let's create a full name column where we will concatenate the first name and the last name of the customer. Let me go ahead and do that. I'll create a new column. Let me rename the column as full name. Then I'll take the first name from the orders table, use the ampersand, followed by a space using inverted commas, followed by another ampersand and the last name. I hit enter. You can see we have a full name column. If you go back, so there were 2 columns in the name of first name and last name. Now we have merged both the columns into a single column named full name, and you can see the first name, space and the last name. Now let me give the sales column a currency value. So I'll select the sales column. Here under general, if I go to currency, I can see there are multiple currency symbols. Choose whatever you want. For this video, I'll take dollar English United States. You can see our sales column is now represented by a dollar value. Similarly, let me make some changes to the profit column. As you can see, there are multiple decimal values for each profit. So let's standardize it. So I'll select the profit column, and this is where you can standardize it. Now it's auto. So let me make it 2 decimal places. So our data is ready now. Let's go to the report view and start building our reports. Before that, under the model view, you can see the new columns that we had created. You can see there's weekday, weekend, there's year, there's quarter column, month column. The same you can see under the report view as well. Under fields, you can see these are the columns that we created: days of shipment, day of week, quarter, month, weekday or weekend, and year. Now we are under the report view. First, let me go ahead and create a text box. So under the home tab, you have the text box. I'll select that. Let me stretch it a bit. We'll give a title, sales dashboard. I'll select this and increase the size to, let's say, 28. We make it bold and center align it. Also, under the visualizations tab, under background, we'll add a background color to this text box. Let me select this blue color and let me make the font as white. So now we have our title ready. So under general, you can decrease the height of the text box. Let me make it as 70. First, let us create a new card from the visualizations panel. So under visualizations, there is an option to create new card. I'll click on it. Let me resize. I'll move it to the top. We'll see the total amount of sales or the total revenue that was generated from the sales. After selecting the card, I'll choose sales onto fields. So here you can see it gives you the total sales that were made, so which is nearly $2.3 million. If I go to the Format tab under Data Label, let me switch on the border. Under Title, you can give a new title, for example, Total Revenue. Hit Enter. Now you can increase the text size to say 15 and center line it. You can also change the color of the sales value. So under Data Label, under Colors, you can choose whichever color you want. Similarly, let's create one more card to find the total number of units that were sold. I'll copy the same card, Ctrl C, Ctrl V. I'll move it a little below. Now I'll remove the sales column from the fields and add the quantity column onto fields. Again, under title, I'll edit this title as Total Quantity Sold. Let me create one more card where we'll see the total amount of profit that were made. I'll select this. I'll remove the quantity column and add profit. Under the Format tab, under Title, I'll make this as Total Profit. Hit Enter. Stretch it a bit so that you can see the total amount of profit that were made. Now, let me add a slicer wherein we'll have the order date column. So I'll add the order date column onto fields. So you can see here we have the order date column, and under slicer header, let me increase the text size to 15 and let's switch on the border. You can also give a title to the slicer. So under the Format tab, go to Title, switch it on, and we'll give a title text as Slicer by Order Date. Scroll down, I'll center align it and increase the text size to 15. Now if you want, you can also change the date colors to blue. So under Date Inputs, you can go to Font Color and select any blue color. Now let's create a line and stacked column chart to visualize sales and profit by each year, each month and each quarter. So from the Visualizations tab, let me select Line and Stacked Column Chart. I'll resize this. After that, let me add the order date column onto the shared axis. We'll drag the sales onto column values, and under line values, I'll take the profit column. So here you can see we have the sales and profit by each year. The bars represent the sales and this line represents the profit it made for each year. Let me go to the Format tab and make some changes to the data colors. Let the color of the profit remain the same, but the bars, I'll choose a custom color, give a hexadecimal value like 196273, hit enter. So we have successfully changed the color of the bars. Power BI has an interesting feature where you can drill down the sales by each year, each month, each quarter, or by days. So let me show you. So on the top, it shows you go to the next level in the hierarchy. So if I click on this, here you can see the sales and the profit that were made for each quarter in every year. Quarter 4 for every year made the highest amount of sales and the profit. Similarly, if I drill down further, you can see, let me expand it, you can see by month. This is for each month over all the years how much sales were made. You can check November month gave us the highest amount of sales and December month gave us the highest amount of profit. Similarly, you can still go to the next hierarchy. Here you can see the sales and the profit made for each day over all the years. So day 17 made the highest amount of sales and day 23 gave us the highest amount of profit. If you see the lowest sales and the profit, you can see order date 25 gave us the lowest amount of profit, and similarly you can see day 29 gave us the lowest amount of sales. Now you can also go to the Format tab and switch on the data labels. So you can see here in 2014 we got nearly 49.5k profit and nearly $0.48 million sales. Similarly, in 2015 we had nearly 61.6k profit and 0.47 million sales, and so on. Now let me go ahead to the Format tab and switch on the border. Let me now create a clustered column chart for sales by year and quarter. So from the visualizations, let's select clustered column chart. Let me resize this a bit. And under axis, we'll add the year column. So I'll drag year onto axis. Under legend, I'll take the quarter column. And under values, I'll choose sales. So you can see here the sales that were made under each quarter for each year. This picture clearly says quarter 4 for every year made the highest amount of sales and quarter 1 made the lowest. Let me go to the Format tab and I'll go to the data colors. Let's change the colors for each of these quarters. We'll be using hexadecimal values. So under custom colors for quarter 1, let me select hexadecimal value as follows. So for example, PF D6 D9. Similarly for quarter 2, I'll select 6D9 BA6. For quarter 3, and finally for quarter 4, I'll choose a little darker color. So here is how our clustered column chart looks like, and we can see the sales by year and quarter. Now let me go ahead and let's add a border. Now we'll analyze the sales by each state. So for that, we'll use field map. So I'll click on field map. Let me resize it. Now let me add the state column onto location. Under tooltips, I'll add the sales column. Let me expand it. So you can see here we have the map which shows the sales by each state. Now let's do some color formatting to this. I'll go to the Format tab, click on Add Colors, and blue is the default color. There's an additional option where you can use conditional formatting. So I'll use that. So it gives you the option to choose your color between maximum value and the minimum value. You can also choose this diverging option where you get a center value or a mid value as well. Now for the minimum value, I'll choose a color. Again, I'll use a custom color. It will be similar to a green color. Hit OK. Then let's use some orange color for the mid value range. For example, EB. And similarly, for the maximum value, we'll use a little darker color which looks similar to red. Click enter. So now we have defined our color scheme. Let's click on OK. Let's zoom out. So you can see the states which are in green color made the lowest amount of sales, while those which are in orange or in red made the highest amount of sales. So in this example, you can see California had the highest amount of sales. Similarly, New York is next, is just below California with the amount of sales, followed by Texas. We'll go back. Let me also add a border to this. Similarly, you can also select the profit column or the units sold column to see the units or the profit that were sold by each state. So let me now go ahead and create a donut chart. In that donut chart, we'll analyze the sales and profit by each segment. So under visualizations, I'll click on donut chart. So under legend, I'll add the segment column. Under values, I'll take the sales column, and we also want the profit, so I'll take the profit column onto tooltips. So you can see we have our donut chart prepared, and you can see the sales and profit by each segment. Let me expand this. The donut chart indicates consumer segment made the highest amount of sales and profit, while home office segment made the lowest. I'll go back. Let me go to the format tab, and we'll make some formatting to our data. Let's change the color of all the segments. Choose custom color. Let's give a color coding as 1558C. Similarly, we'll change the color for corporate segment as well. Let's take a gray color. And finally, we'll change the color for home office as well. I'll also switch on the border. So we have our donut chart prepared. Now let's move ahead and create a pie chart to analyze the profit and sales by each category of products. So under visualizations, I'll select pie chart. I'll drag the category column onto legend. Under values, I'll take the profit column, and under tooltips, I'll take the sales column. So you can see we have a simple pie chart that tells you the profit and the sales that were made by each category. As it's evident, category technology made the highest amount of sales and profit, while furniture category made the lowest amount of profit and sales. I'll go back. Under format, I'll change the data colors. Let's go ahead and do that. I'll use custom colors and give a hexadecimal color value. Similarly, for office supplies, I'll take another hexadecimal value. And finally, we'll change the color of the furniture category. Also, let's give a border. So we have a pie chart prepared that tells you the profit and sales by each category of products. Now we are done with our first sales dashboard. So I can go ahead and rename this tab as overall sales. Next, we are going to analyze the sales, profit, quantity sold, and all of these by taking region and the state as filters. So we'll continue with the same drill. First, I'll create a text box. So under home menu, I'll go to text box. I'll stretch this. I'll give a title to this page, for example, region and state level analysis. Let me make it bold, and I'll increase the size to 28, make it center aligned. We'll make the text as white, and under visualizations, let's give a background color. I'll choose this blue color. So let me go ahead and create 3 slicers, a region slicer, a state slicer, and a year slicer. So under visualizations, I'll click on slicer. Let me resize, move it on top. And for region slicer, I need to add region onto fields. So you can see we have a region filter now. Let's do some formatting to this. Under slicer header, let me make the font color white and let's give a background, let's say blue, and let me increase the text size to say 15. You can also choose a font family. Let's go for Calibri, and you can increase the size of the items. Let's increase the text size to say 15, and let's give a border. So now you have the region slicer ready. Let me copy paste this. Next, we'll create the state slicer. So I'll remove region from here and add state onto the field. So you can see we have the state slicer ready. Similarly, you can also go ahead and create a year slicer where you can analyze the sales and profit or quantity by year. I'll remove state from here and I'll drag the year column onto field. You can see we have all the 4 years from 2014 to 2017. Now sometimes it might be difficult for you to scroll through all the values present in a slicer. For example, in the state slicer, you can see there are multiple states. And if you want to filter your report by a particular state, you have to always scroll down or scroll up and check manually where the state is. So Power BI gives you this feature where you can use the search option. So if I click on this, you can see there's a search option. Select that. So now in the search bar, you can search for any state you are looking for. For example, if you want to search for California state, you can just type on California. So I have just typed CAL and it shows me California. That's an important feature that Power BI gives you. So let me now go ahead and create a simple table where we will see the quantity and the profit made in each city. So under visualizations, I'll select tables. Let me resize this. So under values, first I'll add the city column, followed by the quantity column and the profit column. Let's do some formatting. So under column headers, let me change the font color to white and let's add a background. Let me increase the text size also. Let's make it 15. Similarly, if you scroll down under values, let's increase the text size to 15 as well. And let's choose the font family. Let's take Consolas. So here you can see all the cities, the quantity sold in each city and the profit that was made in each of these cities. Now let me add a border to this. So now you can filter each of these cities by region or by state. For example, if I choose Central as my region, it will give you all the cities that lie in the central region. Similarly, you can also search for any state. For example, I am taking Minnesota. So under Minnesota, you can see all the cities and the quantity as well as the profit they made. Let me now uncheck the filters. Now let me go ahead and filter this table in terms of profit. So I'll sort by profit. You can see we have our cities sorted in terms of profit. So New York City made the highest amount of profit, followed by Los Angeles and Seattle. Below you can see the total units that were sold and the total profit that was made from all the cities. So you can also filter down the quantity sold and the profit made by each year as well as by region and state. So let's see. Suppose I am choosing East as the region. So under East, it tells you the states that are present. Let's go for Delaware and let's select 2016 as my year. So you can see the cities that lie under Delaware state and the quantity as well as the profit they made in 2016. Similarly, let's select Massachusetts as the state and let's go for another year, for example 2017. You can see all the cities that are present under Massachusetts, the quantity sold and the profit that was made. Below you can see the total quantity and the profit. Let me uncheck all these. Now moving ahead, let's analyze the sales by each state and the category of product. For this, we'll create a clustered bar chart. So under visualizations, I'll select clustered bar chart. Let me resize a bit. Under axis, I'll take the state column. I'll take category onto legend, and under values, I'll put the sales column. So you can see here, we have the sales for each category under each state. For example, California state made the highest amount of sales under technology category and it made the lowest amount of sales under office supplies. If I scroll down, you can see all the states and the sales they made for each category. I'll go back to the report. Now let's use some filters. You can filter here. For example, if I want to check the sales by each state and category for 2015, I can just click on 2015 and it will tell you the sales that were made. Now let's do some formatting to this bar chart. We'll change the colors for each of the categories. Similarly, we'll change the color for office supplies. And finally, for the technology. So now we have our bar chart ready. Moving on, now let me add a border to this bar chart. Okay. So now that we have seen our sales by state and category, let's now check the profit by year and category. For that, we'll create an area chart. I'll resize this chart. Now, under axis, I'll take the year column. Under legend, I'll take the category column. And under values, I'll take profit. And so we have our area chart that depicts the profit by each year and the category to which the product belongs to. I'll go to the Format tab and under Data Colors, I'll choose some colors. Let's change furniture to this blue color. I'll take office supplies a red color and technology I'll use a green color. So now you can use the filters. For example, you can check the profit that was made by each year and category under East region. So you can see here, in 2017, technology made the highest amount of profit while furniture had the lowest. Similarly, let's check for South region. So you can see in South region in 2016, technology made the highest amount of profit and furniture made the lowest. In 2017, office supplies made the highest amount of profit and furniture was the lowest. I'll uncheck this South region filter. Similarly, you can also see the sales by each state. So under state slicer, you can choose whichever state you want and check the profit it made by that year or category. For example, I'll choose Connecticut. So you can see the profit Connecticut state made in each of these years. I'll uncheck it. Let us move ahead and now let's see profit that was made and the quantity that was sold by each category and subcategory of the product. So for this, I'll choose the line and clustered column chart. So I'll select from the visualizations. Now under shared axis, I'll select the category column. Under column series, I'll take the subcategory column. Under column values, I'll choose profit and I'll choose quantity under the tooltips. So now you can see the profit that was made under each category and the subcategory. For technology category, copiers subcategory made the highest amount of profit. The quantity sold was 234. Similarly, if you check for furniture category, we didn't make any profit for tables subcategory and as well as for bookcases. Under office supplies, paper subcategory made the highest amount of profit. Now let me go ahead and add a border to this. Fine. Moving ahead, now we will see the sales by each segment. For that, let's create a funnel. So from visualizations, I'll take the funnel and I'll drag segment onto group and the sales column onto values. So you can see here the sales that were made by each segment. This picture clearly depicts that consumer segment made the highest amount of sales. Next was corporate and then home office. Now let's do some color formatting. So the default color is this blue. I'll click on show all. Now we'll give individual colors to each of the segments. Using custom color, let's give a hexadecimal value. Similarly, we'll change the color for the corporate segment. And finally, for the home office segment. Now let me go ahead and give a border to it. So if you want to analyze the sales by segment and for a particular region or state or any particular year, you can do that. So let's select for East region and let's take New Jersey as the state for year 2014 suppose. So you can see here corporate segment made the highest amount of sales followed by consumer and home office. Let me uncheck these filters. So our second report is ready where we analyzed the sales, quantity, profit at region level, state level and by year. So I can rename this as region and state. Next, we will analyze the sales, quantity, profit in terms of categories and subcategory of products. So let me first copy this text box and create a new tab. I'll paste that text box here and change the title to say category and subcategory level analysis. First, we'll create a slicer where we'll take the category as filter. So if I want, I can directly copy it from my previous tab and change the fields. So let me copy this and paste it here. I'll sync it, and let me remove the region field and add category onto the field. So you can see we have the 3 categories here. Let me copy paste this again, and let me take the subcategory now. So I'll select this and I'll drag subcategory onto the field. So here you can see we have all the subcategories, and above we have the categories. Let me resize this a bit. With that, now let's analyze the sales and profit by region and segment. To do this, we'll use a tree map. So let's see how you can build a tree map. Under visualizations, I have tree map. Let me select it. I'll move it to the top and expand it a bit. Now, under group, I'll select a region column. Under details, I'll take segment. I'll take the sales column under values, and let's take profit onto tooltips. So if I expand this, you can see the sales and profit by each region and segment. For example, in the West region, you have consumer, corporate and home office as the segments, and you can see consumer segment made the highest amount of sales and profit, while home office made the lowest amount of sales and profit. Similarly, you can check for the other regions as well. Now let's give a border to this tree map, and under data colors, let me change the color of the regions. Scroll down, custom color. Let me choose my own color. Let's take this as a gray color. And finally, for the West region. So now you can select individual categories and subcategories to check the sales and profit by region and segment. For example, if I select furniture as my category, you can see the changes that were made to the tree map. You can also select office supplies and see how the sales and profit changes. Similarly, you can also go ahead and select whatever subcategories you want and then check the sales and profit by region and segment. With that, let me now create a pie chart to see the quantity and the sales by each segment. So I'll go and select a pie chart. Let me resize this. If you want, you can increase the size of this tree map also. So let me go ahead and select segment onto the legend. Under values, I'll take quantity and sales under tooltips. So this pie chart depicts the quantity and the sales that were made by each segment. As you can see, consumer segment made the highest amount of sales and had the highest quantity sold, while home office had the least number of quantity sold and the least number of sales. Let's add a border and change the data colors. Similarly, I'll change the color for the corporate segment. Let's make this gray, and home office, I'll take the following color. Move this a little to the right. Now, let's build a scatter plot to analyze the sales, quantity and profit by each subcategory. So under visualizations, I'll select scatter plot. I'll resize this. So I'll add subcategory onto legend. Then I'll add sales onto the x-axis, quantity sold onto the y-axis, and under size we'll take the profit column. If I expand this, you can see the sales, quantity and the profit that was made for each subcategory of products. You can see here subcategory phone has given us a significant amount of sales with less number of quantities sold, and it has given us a good amount of profit also. Similarly, subcategory chairs has also given us good amount of sales with close to 2356 quantities sold and a good amount of profit. If you see this one, which is subcategory paper, it gave us less amount of sales with more quantities sold, while it gave us good amount of profit though. So you may promote phones or for example chairs to sell more, since it gives you more amount of profit with less quantity sold. Let's add a border to this. You can use the category filter. Suppose if I choose for furniture and expand this, you can see under furniture subcategory furnishings gave us the lowest amount of sales with the highest number of quantities sold, but it gave us a decent amount of profit. Subcategory tables gave us a decent amount of sales with lesser number of quantities sold but didn't give us any profit. Subcategory chairs gave us the highest amount of sales and also the profit. I'll uncheck this. Let's now create a line chart where we can see the profit by each year and quarter. So under visualizations, I'll select line chart. Let me resize this. So under axis, I'll take year. Under legend, I'll take the quarter column, and under values, I'll take the profit column. So now you can see the profit that was made each year and the lines depict each quarter. So if you check for 2014, quarter 4 made the highest amount of profit, while quarter 2 made the lowest amount of profit, while quarter 1 made the lowest amount of profit. Similarly, if you see for 2016, you can see quarter 4 made the highest amount of profit, while quarter 1 made the lowest. If you check for 2017, you see quarter 3 and quarter 4 almost made the same amount of profit, while quarter 2 made the lowest amount of profit. I go back. Now you can filter these by categories also. Suppose if I see for technology, you can check the amount of profit that was made in each year and in each quarter for technology category. Let's add a border to this. Likewise, we'll now create another line chart that will depict the sales by each year and quarter. So let me copy paste this. I'll drag this to the right. Now I'll remove profit from values and add sales. Let me uncheck this also. So here you can see we have the sales by each year and quarter. Now if you see for 2014, again quarter 4 made the highest amount of sales and quarter 1 in 2014 made the lowest. If you see for 2016, you can see 2016 also quarter 4 made the highest amount of sales and quarter 1 made the lowest. I'll go back. So our final report is ready, where we analyzed the sales, quantity sold, the profit at category and subcategory level. I can go ahead and rename this as category and subcategory. Let me save this. Now if you want, you can also filter it by subcategories. For example, if I select chairs as my subcategory, so for chairs you can see the sales that was made by each year and quarter. So in 2017, quarter 4 made the highest amount of sales, while quarter 1 made the lowest amount of sales for chairs. Similarly, you can select other subcategories also. For example, let me take some other category like machines. Let's see the profit now. So for machines subcategory, you can see in 2014, quarter 4 made the highest amount of profit, while quarter 3 made the lowest amount of profit. Now if you check for 2015, you can see quarter 3 made the highest amount of profit in chairs, while quarter 1 made the lowest amount of profit. Let's uncheck this. So now we are almost done building our report using the Superstore sample dataset. So we have our 3 reports ready. You can see the first one was overall sales. The second report we created by taking region, state and the year as filters. So we had a region and state level analysis. And finally, we analyzed the sales quantity and the profit sold by category and subcategory. So I have arranged all these graphs and charts so that it looks a little better. Now let me go to this publish option on the top so that we can publish this report onto the Power BI dashboard. So I'll click on publish. I'll save it. You can select the destination. Here I have only one destination, which is my workspace. So I'll choose it and select. So there you go. Publishing to Power BI, it was successful. I'll close it and let me move to my Power BI service. I'll refresh it for once. So under my workspace, you can see we have the dashboard report. So below you can see there are 3 tabs that we created. The first one is overall sales. The second one is sales by region. And the third one is by category and subcategory. Now, to put these reports onto the dashboard, I need to pin each one of these visualizations. So let me pin one by one. So it asks where would you want to pin it to. I'll select the existing dashboard. Or better, let's create a new dashboard. Let's say Power BI dashboard, spin it. I'll close this. Similarly, let's spin the remaining ones. I'll select Power BI dashboard again, pin it. Let's spin everything. So this slicer, you can't pin it. Let's do the remaining ones. Same will do for the donut chart as well as for the pie chart. Now if I go to my dashboards and select Power BI dashboard, you can see we have a one-page dashboard here. You can resize all the charts and graphs. Let me resize it and move it to the top. So we have our first canvas here, which tells you the overall sales, the profit and the units that were sold over different states, different segments, and by categories. So one of the important features that Power BI service gives you is that you can ask questions about your data and it will tell you what the exact solution is. For example, you can see here you have a field where you can ask questions. So for example, if I type total sales and hit enter, so it tells you the total amount of sales that were made, which is $2.3 million. Similarly, if I want to find out the total profit, I can search for it here, hit enter. It will give you the exact amount of profit that was made. Let's do something else. For example, if you want total profit by say year, I'll hit enter. It gives you a nice line chart where you can see the total profit that was made over all the 4 years. Next, suppose I search for total quantity sold by segment. See, it gives me a bar chart where you can see the total quantity that was sold, and it gives you a list of options where you can find out the total quantity that was sold by city, state, order ID, first name, last name, and many others. So consumer segment had the highest quantity sold. Let's see for something else. For example, if you want the total sales by, say, subcategory, I'll choose the first one. See, you have all the subcategories and the total sales that they made. So it's a very interesting feature that Power BI gives you. Go back. Now, if you want, you can go to the report menu, and if you want, you can pin the other visualizations as well. So another important feature about Power BI dashboard is that you can derive insights from the visualization. For example, if I click on these dots, there's an option you find, View Insights. I'll select it. So on the right, you can see Power BI has itself given us some insights from the data and the visualizations we have made. You can see sales by year and quarter, the sales by day of week and quarter, sales by shipment mode, where you can see the standard class ship mode made the highest amount of sales. You can also see the sales and count of city by year, and many more.
Now, scatter plots are a plot of each individual data point in the data. Two variables are plotted against one another, and each data point on the x-axis has a corresponding individually plotted value on the y-axis. As a result, the plot looks like a bunch of scattered points. These are some examples of scatter charts. Here, each point on the chart corresponds to a value on the x-axis and its respective value on the y-axis. Using scatter plots, we can see how two different variables correspond to each other. Now, let's see how we can plot scatter charts using bouquet. So the first thing that we're going to be doing is importing all of the necessary modules for our Python project. The first module that we're going to need is the Pandas module, which is used to work on data frames. Next, we will also be importing the Pandas bouquet module, which is used to implement bouquet on Pandas data frames. Next, we will import bouquet.io, which we will use to show the various graphs that we are plotting. We will also import bouquet.plotting, which will help us in plotting all of the various graphs that we're going to be looking at. We'll also import glob, a module which will help us merge our files and get them in the required format. So the first line of code that we're going to be writing is pandas_bouquet.output_notebook. This is basically just a line of code which will help you see your output in the same notebook itself. Now let's see how we can plot scatter plots in bouquet. We already have imported the figure function from bouquet.plotting. The figure function contains most of the plots that we want to plot, such as line plots, scatter plots, bar charts, etc. So this is what we're going to be using. The first thing that you're going to need to do is create a figure. So how do we do that? Let's create a random variable p, and this we're going to be initializing to the figure function. Now within this figure function, we're just going to add a couple of parameters for our figure itself. So let's say we want the plot width to be equal to 400 and the plot height to be equal to 402. We're going to be plotting a scatter plot in the form of a square here. Next, we know that a scatter plot is nothing but various circles which are plotted on top of our graph. So that's what we're going to do. We're going to be plotting circles at certain coordinates which are going to be given by our lists. So the first coordinate is going to be the x-axis, and the next list that you're passing in is going to represent the y-axis coordinates. So over here, let's just plot this as 1, 2, 3, 4 and 5, And over here, let's start with 4, 7. These are all just random points. This is just to show you how exactly you can plot a graph in bokeh. And now let's just say that we want the size of the circles to be equal to 10 and the color of every circle to be navy. We're also going to give a random parameter called alpha and equate that to 0.5. This will just act as a placeholder. Now over here, you've initialized your figure function and given it certain parameters. And using this figure function, you're calling the circle attribute of it, passing in other parameters such as the x-axis coordinates and the y-axis coordinates, the size of the circle, the color of each circle, and a random parameter called alpha. So now we've imported all of our modules. And this is how you plot a scatter chart in bokeh. The same thing can be done when you look at the line plot. All you have to do is initialize your figure function and call the line attribute of it, pass in your x-axis coordinates and your y-axis coordinates, maybe pass in a couple of other parameters that are required, such as the width that you want the line to be and the color that you want the line to be, and finally all you have to do is show the plot. This is a basic overview of how you can use bokeh to plot graphs. And here we have a line plot. So the main difference between the scatter plot here and the line plot here is that the line plot has various different points which are connected to each other with the help of a line. So again, what exactly are line charts? A line chart is a chart that represents data as a series of points which are connected to each other with the help of a line. It is used to see trends in our data and track the way data changes over a period of time. So this is the same chart that we just plotted using bokeh right now. So as you can see, so the parameters that you know were passed in were 1, 2, 3, 4 and 5 on the x-axis and 3, 1, 2, 6 and 5 on the y-axis. So how exactly the line chart is plotted is that you plot each of these points and then you connect them or join them using a line. Next, let's take a look at pie charts and how they can be implemented in bokeh. But first, what exactly is a pie chart? A pie chart is a circular chart which is divided into slices to represent how much of the data belongs to a certain category. It is a quick and easy way to see the categories in our data and the percentage of the data set that they represent. On the other hand, you have another type of chart called a donut chart. Donut charts are like pie charts with a hole in the center. And in this hole, you can use it to represent extra data, or you can draw a pie chart within that hole itself. So this is an example of a pie chart. Using this, you can easily get to know the various categories that our data is divided into and the percentage that each of these categories contribute towards our data. Like over here, we have a pie chart which represents crewmates and imposters in a game called Among Us. So using this, we can just say that around 75% of our data is crewmates and 25% of it is imposters. On the other hand, you have a donut chart, which is almost exactly the same as a pie chart, except the middle portion is missing values. And in this middle portion, you can do other things such as plot a pie chart or represent other data within it. So now let's see how we can plot our pie plots using Python bokeh. But first, we need to import the data that we're going to be using to plot all of this. So the data that we're going to be looking at is the Among Us data. Among Us, as you might know, is a game that caused quite a frenzy in the past 2 years. So the data that we're going to be working at is the Among Us data set that you can find on Kaggle. Among Us was the new craze for people playing mobile games that suddenly exploded in popularity and became a hit video game during the pandemic. Now Among Us is basically a multiplayer game where 4 to 10 players are dropped in an alien spaceship. Each player has their own role of imposter or crewmate. The task of the crewmate is to run around the spaceship to complete various tasks which are assigned to them and also to not get killed by an imposter. Players can be voted off the ship, so each game becomes one of survival. So let's load this data set and create more features. So now we've imported our data set. As you can see, our data set has over 2000 rows and 14 columns. The first column that I want to show you is the user ID column. The user ID column tells us which user the game data was collected from. Now there are 14 columns. The game completed data tells us the date and time of game completion. The team tells us if the player is an imposter or a crewmate. The outcome tells us if the game was won or lost. So over here, this is each game that a certain user has played. The user ID is used to represent the user who has played the game, and as you can see, we've collected data from 29 different people. And the number of games that these 29 people totally have played is over 2000. The outcome tells us whether the user has won or lost in this game. The task completed tells us how many tasks was completed by this user in this game. All tasks completed tells us whether the user was able to finish their tasks. Murder tells us if the user was murdered. And imposter kills tells us the number of kills by the imposter. So if the user was not an imposter, we do not have data on how many kills was committed by the imposter during that particular game. That's why this column has a lot of missing values. Game length tells us the total duration of the game, and ejected tells us if the player was ejected or thrown off of the spaceship by their fellow players. Sabotage is fixed is basically the imposter within the game can create sabotages, and it's the crewmate's duty to fix them. So this tells us the number of sabotages which was fixed by this particular crewmate. Time to complete all tasks tells us the duration taken by the crewmates to complete all the tasks, and the rank change tells us the change in rank after wins or losses of the game. The region or the game code tells us the server and the game code. Now first, let's just see how exactly the data is distributed. So this tells us how many counts each column has. So as you can see here, most of them have the same number of counts except rank change, which has a couple of missing values. Unique tells us how many unique values exist in each column. So obviously team, there will be 2 because there are only 2 possible outcomes. You can either be a crewmate or you can either be an imposter. Outcome also has only 2 unique values because you either win a game or you lose a game. Task completed has 12 different values, and this is because the number of tasks which have been completed probably range from 1 to 12. All tasks completed has 3 values, which is yes, no, and missing data. And the same goes for murdered. You have yes, no, or missing data. Imposter kills tells us how many kills the imposter has made. So in this case, the most kills that the person has made is probably 9. Game length, there are 988 different values, and ejected, again there are only 2 values because you can either be ejected or you can either stay in the game. Now the top value tells us the most frequently occurring value, and the frequency tells us the frequencies of all of the top values. Now let's create a feature called minute and extract data from game length. So we're going to be splitting the game length column, which is this column, and we're going to be converting it into minutes. And then we're going to be using that data and creating a separate feature column called minutes out of it. So let's do this. So these are the first top 2 values of our minutes of our new minutes column. The 0th value is 7 because the first game length that you see here was of 7 minutes. So all that we're doing is that we're going to be splitting this value, which is 7 minutes 4 seconds, and we're going to be keeping only the first value, which is that of the minutes. The second minutes value is 16 minutes, and that corresponds to the second value in our minutes feature variable. Now let's take a look at the murdered column. The murdered column has yes, no values and missing data set and missing values. So let's change those. We're going to be replacing no values with not murdered, yes values with murdered, and the simple dash with missing. And we're going to be doing this in place, which basically means that this is going to make a change to our main data frame. So this is done. Let's take a look at our data frame now. This is what our data frame looks like. We have a game's length column, we have a minutes column, and we also have made changes to our murdered column, which is represented here. So now we don't have any missing values or dashes in our murdered column. We have all of it represented as categorical data. And this is one of the main columns that we're going to be using to plot our pie plots. So now let's see how we can plot a pie chart. The first thing that we're going to be doing is that we're going to be getting the total value counts in our team column here. So we're going to be plotting a pie chart with the help of this team column, and we're going to be getting the value counts of each unique value in the team column. So you can do this with the help of the value counts function that Pandas data frames provides us with. And now that we have the value counts of each unique value which is present in our team column, let's plot it in the form of a pie chart. We're going to be doing this with the help of the plot bouquet function. And the type of chart that we want to plot is a pie chart. Let's give it the title as ratio of imposters versus crewmates, and let's run this now. And this is what your pie plot looks like after you've plotted it. So now the same thing can be done to plot a donut plot. The first thing that we want to see is if there are more crewmates or imposters murdered or not in the game. To do this, we will add two more features, angle and color, which are going to be used in the chart. So to get angle, we're going to be importing pi from math, and we're going to be converting our angle in the form of radians. And as for the color feature, we're going to be having 3 different shades of blue. So this is basically what our murdered data frame looks like. So over here you have not murdered, the total value counts of which is 894, and the angle that this gives us is 2.522302, and this is the corresponding color. The same goes for murdered, which is 867 values, and we've converted that into an angle in radians and given it its own color. And finally we also have missing values, of which there are 466. The angle is 1.314756 and it has its own corresponding color. So this is a data frame that we're going to be using to plot our donut chart. So from bouquet.transform we import cumulative sum, and the cumulative sum is what we're going to be using to find the start of our angle, or basically to find how much portion of our donut chart is going to be occupied by the angle. So the donut chart can be plotted using the angular wedge function from figure. So the x-axis here is 0 and the y-axis is 1. The inner radius is the radius that you are going to be giving to the inner smaller circle, and that we've given as 0.15. The outer radius is the radius of the bigger outer circle, and the direction in which our data is going to be plotted is in the anti-clockwise direction. So let's run this. And this is what our donut chart looks like. So the not murdered is this dark blue color portion of our donut chart, and when you And when you hover over it, you can see how many values are present in the not murdered column. The same goes for murdered, and because we've plotted our data in the anti-clockwise function, this is how it's being plotted. So murdered, not murdered, and then finally you have the missing values. The way that you can interpret this graph is that you can say that most of the people were murdered during the game, but most of the data is missing. So we can't say for certain whether the majority of the people were murdered during the game or not, because the number of missing values can make a huge difference. And the number of people who were not murdered and the number of people who were murdered are very close to each other. Like their total values are very close to each other. Next, we will create a data frame of sabotage as fixed and minutes and change the column name and add T in them. So this is basically what we're doing. We've created a data frame which has the number of sabotages fixed and the minutes. Now let's just take the 3 sabotages which were fixed, which is 0, 1 and 2, and create a data frame out of all of these. So each of these individual data frames just contains these individual columns. To make a simple scatter plot with only one legend, we can pass the data and use scatter to make the charts. So basically we're just plotting the scatter chart in bokeh here. And this is what our minutes scatter chart looks like. Now we're plotting this for 1t. We're plotting the minute at which one sabotage was fixed. And another cool thing about bokeh charts is that you can always zoom into them or zoom out of them to better see where your data is plotted. So this is a scatter chart which has only one variable, which is 1t and the minute at which it was plotted. To make a scatter chart with more variables, we are going to need to use circle, which is a method of figure object which we've already seen before. The circle is one of the many plotting styles which are provided by bokeh. You can also use triangles or many more. You don't have to make each point a circle. So we're going to be plotting the sabotages fixed and the minute at which they were fixed. And we're going to be plotting 3 different circles of 3 different colors. I mean, each of them correspond to how many sabotages were fixed at what time. 0 sabotages at what time, 1 sabotage at what time, and 2 at what time. So let's run this. So as you can see here, when 0 sabotages were fixed, these were the times. When 1 was fixed, this was the time at which it was fixed. And when 2 was fixed, this is the time that it was fixed at. Now the x-axis is our minutes and the y-axis is the sabotage. When you hover over it, you can see various information about where each circle is plotted. So this has an index of 10. The data xy will tell you the exact x coordinate and the y coordinate, and the screen xy will tell you the screen pixels on which it is plotted. So now we've taken a look at pie charts. Let's move on to histograms. So what exactly is a histogram? Histograms are used to plot numerical data according to the range that they fall into. The data is plotted in the form of bins or rectangles, and the y-axis corresponds to the amount of data present in a certain range or at a certain point. So this is what a histogram looks like. This is a histogram of the distribution of minutes. So the x-axis has the range within which this data falls. Like over here, the first range is from 0 to 2.9 and the second one is from 2.9 to 5.8. Each range has a value of 2.9 and the corresponding y-axis or the height of the bins tells us how much data is present within this range. So this is how you can read histograms. Now let's see how we can plot them using Python bokeh. Now let's see the distribution of minutes in the Among Us game. We will use hist to plot a histogram. So basically just going to be plotting the minutes of our game we're going to be using the df min column for this, and we're going to be converting it into an integer. So this is the column that we're going to be plotting. Let's plot this. Again, we're going to be using the plot bouquet function here because it makes plotting data frames very easy. The kind of data frame that we're going to be using is the histogram or hist, and the title of our graph is going to be distribution of minutes. So let's run this. Now this is what our histogram looks like. Now this is when we've only plotted one variable, which is minutes. Yeah, so another thing that you can plot is a stacked histogram. A stacked histogram is when you plot various histograms on top of each other. So let's see how this works. For a stacked histogram, we want to see if the game length has a correlation with the amount of imposters and crewmates in our game. So to do this, we're going to be creating a small data frame which has the game length and the team columns combined. So let's do that. And this is what this looks like. So all you have to do to plot this in the form of a stacked histogram is use the hist function again. So let's see how that is done. And let's give this figure a size of, say, 750, 350 size. So let's run this again. And this is the stacked histogram that you get. We have two different columns which are plotted on top of each other versus the game length. So basically this tells us that when the game length was between 0 to 0.9 minutes, the number of imposters was way higher than the number of crewmates. And the longer the game went on, the number of imposters decreased and the number of crewmates just kept getting longer and longer. Now, obviously, you can say that the number of crewmates is decreasing as the game goes on too, but this is because the imposters would have killed off most of the crewmates. As you can see here, towards the end, there are no imposters, which means that most of the imposters were rejected and the crewmates won. So now we've taken a look at histograms. Let's move on to bar plots and understand how exactly they're different from histograms. So in histograms, you have plotted numerical data distributions as of yet. In bar plots, you plot for categorical data. It also uses bins to plot the amount of data. When the bins are stacked on top of each other, it's called a stacked bar chart. This is basically what a bar chart looks like. The difference is this does not have its own range. Each bar is used to represent a categorical data, and the height is used to tell us how much of that categorical data is present. So now let's see how we can plot a bar plot. So again, we're going to be making a small data frame of the task completed and the value counts of how many tasks have been completed. To plot a bar plot, we're going to be using plot bouquet again, and the kind of plot that we want to plot is bar. So let's run this and see what we get. So here is your bar plot. The task completed in this case is categorical data, and the counts basically tells us how many value counts fall into each category. So 0 tasks completed are 69, 1 task completed is 117, 2 tasks completed is 10, and so on. From this bar chart, you can say that the most number of tasks completed is 7 and the least tasks completed are 10. Now let's create a stacked bar chart and let's see who wins, imposters or crewmates. To create a stacked bar chart, what we're going to be doing is that we're going to be creating a different smaller data frame of team and outcome. To make sure that the bar chart is stacked, all you have to do is include a stacked attribute in your bar function and change its value to true. So let's run this and see. And here you can see that we have a stacked bar chart. So you can see that crewmates who have a lot more data have won 981 times and lost 780 times, while imposters have lost 205 times and won 216 times. So the crewmates have won significantly far more than the number of times imposters have won. Now let's take a look at stacked vertical bar charts. So far the bar charts that we've been looking at have been horizontal, which means that the data goes upwards. For a vertical bar chart, we're going to be seeing if all tasks have been completed or not. So in the data frame column, all tasks completed, we're going to be replacing the values of yes and no with tasks completed and tasks not completed. We're also going to be creating a smaller data frame of the outcome column and the task completed column. To plot a stacked vertical bar chart, you are going to be using Python bouquet.barh function, and you're going to be changing the stacked attribute to true. This is what a stacked horizontal bar chart looks like. So over here we can see that the missing values is represented by blue, tasks completed by orange, and tasks not completed by green. Here you can see the total outcome. You can see how many wins, how many tasks are completed, and how many tasks are not yet completed. And the same goes for losses. You can see how many losses have occurred, how many tasks were completed, and how many tasks were not completed. This is a very good way of representing a lot of data in a relatively smaller area. Now, the way we can interpret this graph is that we can say that finishing the task will automatically ensure that the crewmates have won. So there's a higher number of people who need to complete the task to win the game. Another very unique type of bar chart that you can have is a bidirectional bar chart. So let's plot a bidirectional bar chart in which the bars will be going both ways, to the left and to the right. We're going to be plotting a horizontal bar chart over here to make it easier for you to see. To have a bidirectional bar chart, you need positive values and negative values. The center is going to be at 0. So here we're going to be making the loss feature as negative by multiplying the loss feature with the -1 value. So here we go, the losses are all negatives and the wins are all positives, right? Now let's run this and see how many losses and wins have occurred for each user. So user 1 has 42 losses and 58 wins, but you can easily see whether they have won more or lost more by comparing the height of the bars for the wins and the losses. So we can easily say that in this scenario, user 1 has won more times than they've lost. The same can be said for user 2, where the wins bar is significantly higher than the losses bar. So this is how you can plot and understand a bidirectional bar chart. So we've taken a look at how we can plot bar charts and the various types of bar charts that are available to us in Python Bouquet.
Data isn't just about charts, it's about proof. Statistical analysis helps you validate your assumptions, test theories, and uncover patterns with confidence. In this section, we'll break down concepts like hypothesis testing and correlation into simple, useful insights.
The table explains how a decision can be made based upon the hypothesis testing. Type 1 error rejects the null hypothesis when it is true. The probability of making type 1 error is represented by alpha. Type 2 error fails to reject the null hypothesis when it is false. The probability of making type 2 error is represented by beta. Probability value. The probability of observing extreme values, or more extreme than the one observed, calculated from collected data. Let's understand the process of hypothesis testing. The first step is to set the hypothesis. The hypothesis could be null or alternative. The null hypothesis, or H0, states that a population parameter is equal to a value. The alternative hypothesis, or H1, states that the population parameter is different than the value of the population parameter in the null hypothesis. The alternative hypothesis is what is believed to be true or is to be proven true. The next step is to set alpha, or choose the significant level for the population. The third step is to collect the sample from the population, which represents the characteristics of the population. The final step is to compare the p-value and alpha. You reject the null hypothesis if p-value is less than alpha, and fail to reject the null hypothesis if p-value is greater than or equal to alpha. This example shows how clinical trials can be analyzed. Suppose a pharmaceutical company wants to compare a medicine it manufactures with that of a competitor's medicine. Then, hypothesis testing can be the method it adopts. The null hypothesis would be that both the medicines are equally effective. The alternative hypothesis would be that the two medicines are not equally effective. There are three types of data on which you can perform hypothesis testing. Continuous data. Evaluate the mean, median, standard deviation, or variance. If you take the same example to test the efficacy of medicine, take the temperature of every person in the sample after 3 hours of administering the medicine. This would be referred to as continuous data. Binomial data. Evaluate the percentage general classification of data. When data is divided into two categories, you obtain binomial data. Supposing the same population were asked if their fever had subsided and the answers could be yes or no, then the percentage who said yes should match the null hypothesis. Poison data. Evaluate rate of occurrence of frequency. If the sample is asked about how many times in a month they use the medicine, and the rate of frequency is recorded and is then compared to the null hypothesis, where the rate should be less than a certain number. Here is the example of a correlation matrix calculated for the stock market. We can choose the data variables and calculate the correlation matrix to demonstrate the short, medium, and long-term relationships between them. Now you can see why a correlation matrix would prove useful for traders.
This concludes our introduction to data analytics, where we have uncovered its meaning, the role of analyst, and the initial steps in handling data from various sources. We have explored structured, semi-structured, and unstructured data and learned basic descriptive analysis techniques. As you continue, you will master tools like Excel and Python for deeper analysis and visualizations. This foundation knowledge empowers you to extract valuable insights and make data-driven decisions. The journey of data exploration has just begun, and your ability to analyze information will be a powerful asset in the future. Keep learning and exploring the power of data.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.